Last class we were talking of the volcanoes, right? And in volcanoes we have completed up to the intrusive volcanoes. हो गया है ना? Intrusive? No sir. हो गया है ना? Right. Intrusive done and extrusive also we have done. All the types. Okay. So no major doubt up to here. कुछ है major doubt? So this was a classification on the basis of what? The classification that we did? On the basis of the extrusive one was on the basis of the nature of the magma or the lava. Lava. Very good, very good. ठीक है, अच्छा है, पढ़ लिया फिर. So on the basis of the nature of the lava, and then can you give me the sequence from the most basic to the most acidic formation? नाम देख करके बता सकते हैं? कॉपी में देख लो, कोई बात नहीं, ओपन बुक टेस्ट है. हाँ, most basic is the MOR followed by mantle plume is the most basic. I'm asking the most basic. I'm asking, please listen to the question. Please give me the sequence of the formations from most basic to the most acidic. Mid-oceanic is the most basic, then the shield volcano, then basalt lava plateau or province as you call it. Okay. And all these three are mainly because of basic basaltic type of magma. Okay, clear है इतना? Then next, ash and cinder cone. Okay, then composite cone or the stratovolcano as you call it. Okay. Did you look for the peaks given in the GC Leong? How many of you could afford to open? Afford to buy नहीं पूछा मैंने. Afford to open the GC Leong. आप लोग का लाइफ इतना बिजी, आई कैन अंडरस्टैंड, यू नो. सर आईएएस का तैयारी कर रहे हैं, आप क्या बोल रहे हो? जीसी लियोंग कौन खोलेगा? है ना, हम लोग को घर जाते ही आईएएस का तैयारी शुरू करना पड़ता है. तो बताओ, आईएएस का तैयारी से टाइम मिला जीसी लियोंग खोलने के लिए? राजेंद्र नगर में बहुत टाइप का आईएएस का तैयारी होता है. जाते ही चाय का दुकान पे जाना है, बुक शॉप पे जाना है, मैगजीन शॉप पे जाना है, बहुत सारा चैनल्स देखना है. आईएएस का तैयारी का टाइम उसके बाद ही बुक खोलने का टाइम मिलेगा. यस. सो विच पीक्स कुड यू फाइंड स्ट्रैटोवोल्केनो? गिव मी द नेम्स, लेट अस सी. माउंट फूजी. वेयर इज माउंट फूजी? यूएसए. ये यूएसए कौन बोला था? इधर ही. अच्छा, आपने बोला था. ठीक है. हाँ, फिर नहीं, मैं भी देखना चाहता हूँ यार, कोई नया निकल गया वोल्केनो है. यस. सो माउंट फूजी, देन माउंट पेले. और कहाँ पे है ये? कैरिबियन आइलैंड्स. ओके. और माउंट, ये एनसीईआरटी में, यस में जीसी लियोंग में दिया है. ओके. किस टाइप का है ये? कहाँ मिला ये? एश एंड सिंडर कोन वाले नहीं याद करने हैं. दे आर लेस देन 400 मीटर्स. दे आर, आई थिंक, 2-3 दिए हुए हैं. दो, आई थिंक 1 or 2 नेम्स आर गिवन, बट यूपीएससी डजंट आस्क यू दोस, सो छोड़ सकते हैं. ठीक है, बिकॉज दे आर लेस हाई. राइट, उसमें लिखा है ना 1000 फीट, उसी लाइन में जहां आपने नाम पढ़ा उसी के. ठीक है. सो यस, व्हाट एल्स? आई नीड द नेम्स. बताओ यार, कोई बात नहीं. माउंट एटना. वेसुवियस नहीं मिला? हाँ, वेसुवियस मिला. किसी ने देखा कहाँ है? इटली. ओके, गुड. Why is Vesuvius known? What is the historic importance of the city or the volcano of Vesuvius? What happened? In your history you will read it maybe. अच्छा, मूवी में देखा है. पाऊँ. अच्छा अच्छा, ठीक है, कोई बात नहीं, कहीं भी देखा हो, सच है. So there was, yes, so there was a city at the base of this Vesuvius, right? And that was when Vesuvius erupted, the whole city got completely stratified. People just died the way they were, in their bed, in their, whichever place. So, okay. सो ठीक है. सो दिस इज व्हाट आई वांट दैट यू शुड, ये एक्सरसाइज सबको करना है, आप सभी को करना है, जैसा कुछ लोगों ने किया है. बाकी लोग भी आईएएस का तैयारी से टाइम निकालो और जीसी लियोंग पढ़ लो थोड़ा. तो प्लीज कैन यू डू दिस, बिकॉज ऐसा छोटा मोटा काम मैं आप लोग के लिए छोड़ता रहूंगा. इन द नेक्स्ट थिंग आई एम लीविंग मोर फॉर यू, राइट. वो भी जीसी लियोंग और एनसीईआरटी से यू हैव टू रीड. सो अंटिल अनलेस यू आर रेडी टू डू इट, गड़बड़ होगा. ठीक है, आगे बढ़े. Yes sir. Any major doubt in volcanoes? None. Most of the peaks you could find, most of the peaks you could see. Very good. ठीक है, चलो आगे बढ़ते हैं. So after volcanoes we come to the, okay, I asked you to do one more thing from the GC Liong, classification on the basis of frequency of eruption. Could you do that? उसमें एक पैराग्राफ है डायग्राम के नीचे, वहां पे लिखा हुआ है frequency of eruption. So how many types we have? You have the 3 types such as extinct, dormant and active. ये तीनों आपका दिया है. NCERT doesn't give you this. GC Liong gives you. Could you find it? Very good. ठीक है. So this was another thing, and the last thing that I want you to know about this is the regions, the major volcanic regions in the world. Should we तो वो कर लें? वो भी दिया है GC Liong में, but let us write this down. So I think you can write on the basis of, एक तो वो लाइन भी लिख के रख लो अपना कॉपी में, on the basis of frequency of eruption. I have already dictated this. नहीं ना, हाँ, on the basis of frequency of eruption, the basis of frequency of eruption, extrusive volcano or extrusive volcanic activity is classified, extrusive volcanic activity, come again, louder. अभी आवाज आ रहा है? अभी ठीक है. And you people, can you hear? No, you can't hear. यार एक सेकंड रुको, मुझे अपने थोड़े कान भी साफ करने दो. मुझे आप लोग की भी बात सुनाई नहीं दे रही है, बट ऑब्वियसली आई कैन अंडरस्टैंड. आपके पास तो माइक नहीं है, बट यस, क्या बोल रहे हो? अ बिट लाउडर. ओके, बट आई थिंक, मैम कैन यू आस्क द टेक्निकल पीपल वो पीछे से, मे बी दे हैव टू इंक्रीज द साउंड और समथिंग, बिकॉज आई कांट शाउट लाउडर देन दिस. नहीं तो फिर लगेगा मैं चिल्ला चिल्ला के क्लास ले रहा हूँ. आज तो चाय भी नहीं पिया, बेचने वाला नहीं आया था. अच्छा, सिर्फ आप ही को नहीं सुनाई दे रहा है, बाकियों को भी नहीं सुनाई दे रहा है? कैन यू हियर मी? इज इट अभी ठीक है? चलो ठीक है, लिखो लिखो. फिर जहां पे नहीं सुनाई देगा हाथ खड़ा कर देना, फिर रुक जाऊंगा मैं. सो आई वाज सेइंग, ऑन द बेसिस ऑफ फ्रीक्वेंसी ऑफ इरप्शन, volcanoes can be classified as active volcanoes which have at least erupted within recent times, which have at least erupted within recent times. Erupted within recent times. Second, dormant volcanoes. Dormant volcanoes that are known to have erupted, and show possible signs of eruption. Known to have erupted and show possible signs of eruption. And extinct volcanoes. Extinct volcanoes that have not erupted in historic times. That have not erupted in historic times, but have volcanic features. This is how you come to know of a extinct volcano. Not erupted in historic times, but have volcanic features. I've given you these 3 lines exactly from the GC Liong because almost this is how they will create your prelims question. Right? Match. Okay, or which of the following statements are right. So you should know the characteristic, but please do write further. But this is not a very, but this is not, but this is not a very fixed classification, not a very fixed classification, as extinct volcanoes can become active. Extinct volcanoes can become active, whereas active volcanoes may never erupt. Active volcanoes may never erupt. Okay, so this is one classification. Now, coming to volcanic or volcano distribution. Right, so next subheading, distribution of volcanoes around the world. Distribution of volcanoes around the world. So one of the biggest, so we write number wise, 1, 2, 3, like this, okay? Number 1. The margins of the Pacific plate, margins of the Pacific plate. What type of plate is Pacific? Oceanic or continental at the margin? Mostly oceanic, right? So this is something that you should know, okay? Margins of the Pacific plate subducting at all its ends, subducting at all its ends, is the largest volcanic belt, is the largest volcanic belt in the world. Subducting at all its ends is the largest volcanic belt in the world, having around two-third of all volcanoes, having around two-third of all volcanoes. Okay, so where does this region start from? It starts from almost at the southern tip of South America. Right, starting from southern tip of South America, this region. So you are writing about this region only, within that only. Starting from southern tip of South America, moving along the Andes and Rockies. Starting from southern tip of South America, moving along Andes and Rockies. Moving along Andes and Rockies, and then further moving along the islands like Aleutian, Kurile, Japan, up to New Zealand. Aleutian, Kurile, Japan, up to New Zealand. Right, we have done these islands already. Aleutian, Kurile, ये सब हमने mark किया है. I hope you remember when we are doing oceanic convergence. ठीक है? And going up to New Zealand. Right? So this is Aleutian, this one is Kurile, and then as you go, you find New Zealand here. Right? The whole, you write this way, New Zealand circumferencing circumferencing the Pacific. Also known as Circum-Pacific region. Hence, also known as Circum-Pacific region. Circumferencing the Pacific, hence also known as Circum-Pacific region. And because of the volcanic activity, called as Ring of Fire. Because of the volcanic activity, called as Ring of Fire. Ring of Fire. Okay, full stop. Then, an extension of this belt, an extension of this belt is the Indonesian-Malaysian Islands. Extension of this belt is the Indonesian-Malaysian Island. The Java, Sumatra, Sunda, all those. Is the Indonesian-Malaysian Islands up to Andaman Nicobar. Up to Andaman Nicobar. So in Andaman Nicobar also we have volcanic peaks, right? Like the Barren Island and the Narcondam. These are active volcanoes there. Right? So if you want, you can write these two names also. वैसे ये हम इंडिया में भी लिखेंगे, but if you feel like Barren Island, B-A-R-R-E-N, Barren, and Narcondam Island, Narcondam, N-A-R-K-O-N-D-A-M. Then the second major volcanic region, extends in the Mediterranean, the Vesuvius, Etna, Stromboli, all those. आपका जीसी लियोंग में सारा नाम दिया हुआ है, ठीक है? Is the Mediterranean region, the islands of Mediterranean, where you have these volcanic peaks, right? So Mediterranean, followed by the East African Rift Valley. So you can see here, it starts from here, somewhere here in the Mediterranean, goes like this, and then almost like this, right? So this whole belt. Clear? Why? Because the African plate, the oceanic parts of the African plate are still subducting below the Eurasian plate there. Okay? So this belt, and then the East African Rift Valley. Right? East African Rift Valley. Then another region is the Caribbean Islands. So this is your Caribbean Islands here, this region. Okay, the Caribbean Islands, right? And the Mid-Pacific Islands. Starting from Iceland, going almost down up to here. Right, so all those. Iceland, Azores, Canaries, Cape Verde, all those. Right? So these are called as the Mid-Pacific Islands. Sorry, I'm so sorry. Thank you for staring, है ना? नहीं तो फिर मैं गड़बड़ करता रहता है बोलते. So Mid-Atlantic Islands. Right? Clear? आप लोग ऐसा जब मुझे थोड़ा घूर के देखते रहते हो बोलने के बाद भी, सर तो मैं समझ आता हूँ कुछ तो गड़बड़ हो रहा है. ठीक है? तो okay, good enough. Right? So these are the major volcanic regions that we have. Clear? Right? Okay. So now let us come to the next part, earthquakes. Right? There are two more topics which are related to this, not given in your NCRT, which are hot springs and geysers. Okay, they are not given in your NCRT, but they are given in the GC Leong. I hope the ones who have read might have come across, but let us touch them here itself and complete. वो भी यहाँ लिख लेते हैं, then we'll go to, right? So then you can write within the volcanic wala part only, we can write two more subheadings. Put the subheading like this: hot springs and geysers. Hot springs and geysers. GEYZERS. Z or S, I think both the spellings are there. GEYSERS, right? Something like this. Geysers. So what are hot springs and geysers? Hot spring is nothing but, very simply said, a hot spring is a hot water lake, right? So just for your understanding, first I would like you to write this down. That a hot spring is simply said a hot water lake. A hot spring is simply said a hot water lake. Hot water lake where due to some residual volcanic activity deep below the ground, residual volcanic activity deep below the ground, the groundwater tends to get heated up deep below the ground. The groundwater gets heated up. Groundwater gets heated up and tends to rise gets heated up Shukriya, and tends to rise to near surface. Okay, tends to rise near surface, bringing relatively warmer water to the surface. Known as a hot spring. Okay, so it would be something like this. Look at the board. Please do draw this diagram simultaneously. Okay, so what you have, this is the land surface, this is the hot spring, that's the lake. Okay, and that's the hot water lake. How does it become hot water lake? Because you have some groundwater below. Okay, this is the groundwater. Groundwater or water from some sources coming, you know, and then it goes down into a chamber which would have some volcanic activity. Now this volcanic activity, what does it do? It will make the water warm and it will make it rise. Okay, so this water tends to rise, come to the surface and creates a hot water pool. That is what we call as your hot spring. That's it, simple. Okay, now this volcanic activity might be the residual activity. Residual means it is almost dying, but then some remains, right? Or it could also be in some active zone. Right, so this could be residual or it could also be in active zone. For example, in India, wherever we have hot springs, they are generally because of residual. Means the volcanoes were there maybe millions of years back, maybe when the Himalayas were joining and all that, right? But now that is over. So there is no volcanic activity there now. Okay, but earlier they were. Okay, do we get it? And then, so because of that residual volcanism, we have some hot water springs, for example, in Himalayas. We also have it in some parts of the peninsula, right? So some of them are there, but we don't have an active volcano in India as such in the mainland. Okay. And when you go to some of the volcanic islands such as Japan, New Zealand, Iceland and all, there you get to see a active hot spring. Is this okay? Right? For example, we have one of them in Himachal where we have a Gurdwara also by the name of Manikaran, right? Manikaran Sahib. So that's where we have this hot water spring. Okay, people go there and cook rice in that water. आप सीधा उसमें कपड़ा बांध के और ऐसा चावल लटका दीजिए, वो थोड़ी देर में पक जाएगा. Right? So clear? Do we get it? Now let us do a geyser. What is a geyser? A geyser has a similar structure. Right? So let me copy the same structure and show you how a geyser is slightly different from this. Similar structure but not exactly the same. So see, you have a doubt? हाँ जी बोलो. अच्छा, nothing. ठीक है. अभी ये देखिए. What happens in a geyser is that in the geyser, first let me tell you what is a geyser, what does a geyser behave like, and then, so geysers are basically like hot springs, but they would have something like the pressure cooker का whistle. जैसा वो बोलते हैं ना, pressure cooker का top पे you have this pressure releasing thing. What happens? After a given interval, when the cooker is on, right, there is some pressure that comes out in the form of rising vapor and water. Right? In the geyser also the same thing happens. So when you see a geyser, basically from that you will find some hot water, right, and gases coming out at given intervals. Maybe after an hour, half an hour, 2 hours, something like this, you will get to see the, some high pressure released, right? So it will just come out and then gradually it will settle down. It will be there for a few seconds again. Okay, so this is what we call as a geyser. So it would be a hot spring with a geyser. In many places you might not have so much water, less water, only the geyser might be there. Is this clear? Right. So now let us understand how it happens and then we write about it. So this is the same structure, but we have a mid chamber also in this, a middle chamber where the pressure builds up. So this is the difference in a geyser and a hot spring. In the geyser, you will have a middle chamber also where all this vapor from the side will tend to build up. Okay, so that rising vapor will tend to build pressure in this region. Once the pressure is high enough, just like the pressure cooker, it releases the pressure. Right? That's what you experience on the top. Once that is gone, the pressure is released, then it again settles down. Right? And because it's a continuous activity, so the frequency of that pressure building and release is constant. So you could always experience a geyser. If you go to these geysers, you will get to know that, okay, after half an hour, after 20 minutes, after one day, it will erupt. Is that okay? And it might rise to a few feet or maybe up to maybe 30, 40, 50 feet like that, depending on how much pressure it is building. One of the most famous one is given in your GC Leong as the Old Faithful. Okay? Yellowstone National Park में USA, where we did that mantle plume. I hope you remember, है ना? वो मैंने आपको बताया था. You have this Columbia snake plateau, and there it is because of that Yellowstone. We have this mantle plume there, and there you have that geyser also by the name of Old Faithful. ठीक है, उसका frequency भी दिया हुआ है आपका GC Leong में. Right, that's the most famous, but you have it at many places. We don't have geysers in India. ठीक है, we have hot springs but not geysers. Is this clear? तो अभी लिख लें इसके बारे में. Would you like to draw this diagram? Similar diagram, but वो भी बना लीजिए. It will be easy for you. And I'll dictate that middle chamber thing. Yeah. Just a second. There's a doubt, sir. Are geysers and hot springs found together? No. As I said, in India we have hot springs. We don't have geysers in India. Just give me a moment. Sir, please say smoothly and repeat at least 3 times. I did not get what you said. 2 or third one, please say all which you said in the first time, please. I did not get what you said, dear. ठीक है, 3 times, but 3 times ज़्यादा हो जाएगा यार. मतलब 9 hours का क्लास हो जाएगा. ठीक है. सो नीतीश जी प्लीज थोड़ा सा मतलब कोऑपरेट करिए. ओके, 1 और 2 टाइम में ही. यस. रॉक्स के अंदर ऑसिलेट कैसे कराओगे मिडिल चेंबर को? यू आर टॉकिंग ऑफ द मिडिल चेंबर ऑसिलेशन, द रीजन और द गैसेस? किसका बोल रहे हो आप? गैसेस विल बिल्ड अप प्रेशर. ऑसिलेट मतलब बिल्ड अप प्रेशर ग्रेजुअली. वो प्रेशर कुकर टाइप अरेंजमेंट समझो. ठीक है, राइट, क्लियर? ठीक है, ड्रॉन, एवरीवन शुड बी राइट. वो लिख ले 2-3 लाइन इसके बारे में. ठीक है, दैट विल हेल्प यू विद दैट हॉट स्प्रिंग आल्सो. सो यू कैन राइट that due to the residual volcanic activity, ma'am, I believe this dictation wala, ma'am, nobody else has said about this, na? Everyone is mostly clear. Have you got any complaint about dictation speed, na? Yahi ek hi hai na? ठीक है. So because of the residual volcanic activity, groundwater might heat up. Groundwater might heat up. Groundwater might heat up, causing the rising water to create a pool on the surface. Create a pool on the surface known as hot spring. Create a pool on the surface known as hot springs. On the surface, create a pool on the surface known as hot springs. Okay. Then next paragraph. In regions where the intrusive volcanic activity is intense, in regions where the intrusive volcanic activity is intense, it has to be hot enough, right? Intense, and there are some middle level hollow chambers, middle level hollow chamber created due to intense heating and pressure, comma, periodic buildup of steam pressure generally leads to a fixed interval eruption. A fixed interval generally leads to a fixed interval eruption of steam and boiling water. Steam and boiling water known as geysers. So where will you find geysers? Where you have active volcano. Where can you find hot spring? Even in dormant regions. This is the difference. ठीक है? So for your geyser you need a intense pressure, and for that intense pressure you need a active volcano. Then only active underground volcano, there only you will get it. That's why we don't find geysers in India. Right? We might have some old residual volcanic activity in some parts, but we don't have active volcanic activity inside the ground below. Okay, clear? Clear है? आगे बढ़ जाएं. Right? Can you read slightly from the GC Leong, वही volcano वाला chapter? Right? I hope none of you माइंड व्हेन आई टेल यू टू रीड, आप ये मत सोचना कि सर आप अगर एनसीईआरटी या बुक ही पढ़ना था तो क्लास में क्यों आए. ठीक है, क्लास को यू हैव टू सब्स्टिट्यूट विद योर जीसी लियोंग एंड एनसीईआरटी. दिस इज समथिंग दैट आई विल ऑलवेज गो ऑन एम्फसाइजिंग, बिकॉज फॉर मी द ओनली वे फॉर योर सिलेक्शन इज योर जीसी लियोंग एंड एनसीईआरटी अलॉन्ग विद द क्लास. ठीक है, तो इसलिए वो करना ही है. हाँ जी, कम अगेन, सॉरी. Do you have to read Vision IAS geography notes only where I ask you to? जैसा मैंने शायद शुरू में आपको प्लेट टेक्टोनिक के टाइम पे बोला था, है ना, तो वहां थोड़ा पढ़ लो. मेंटल प्लूम नॉट गिवन इन एनसीईआरटी जीसी लियोंग, वहां थोड़ा पढ़ लो. ठीक है, बट वो टाइम जोन्स के लिए बताया था शायद, तो वहां थोड़ा पढ़ लो, बट नॉट अदरवाइज. जरूरत नहीं है, बिकॉज वी देयर ऑल्सो वी आर डूइंग द सेम थिंग. बट आई वॉन्ट यू टू एटलीस्ट रीड दिस. आई एम नॉट सेइंग वो पढ़ोगे तो नहीं होगा. ऑल आई एम सेइंग इज वो भी होगा, क्योंकि वो भी वहीं से लिखा है. बट इट्स बेटर टू रीड, यू नो, गेट इट डायरेक्टली फ्रॉम द हॉर्सेज माउथ रादर देन इनडायरेक्टली घुमा फिरा करके लो. ठीक है, तो वो पढ़ लोगे आप एनसीईआरटी जीसी लियोंग, तो हमेशा कॉन्फिडेंस रहेगा, हाँ जो सबने पढ़ा था मैंने भी पढ़ा. किसी टॉपर को सुना उसने बोला हो कि मैंने विजन का नोट से एनसीईआरटी पढ़ा था. मेरा इंस्टीट्यूट है, फिर भी बोल रहा हूँ. नहीं बोलता है कोई, क्यों? ठीक है, मैं आपको ऐसे ही बोलता हूँ, नहीं हमारा नोट्स तो सबसे अच्छा है. अच्छा है, आई एम सेइंग दैट, राइट, बहुत अच्छा है. बट स्टिल आई वुड रिकमेंड कि आप एनसीईआरटी और जीसी लियोंग पढ़ो, बिकॉज दैट इज मोर साइकोलॉजिकल. सबने पढ़ा है, मैंने भी पढ़ा है. ठीक है, नहीं तो कल को फिर से आएगा कि सर ने मुझे एनसीईआरटी नहीं पढ़ने दिया. हाँ, सर ने बोला नहीं विजन का नोट्स पढ़ लो. आता है ना, जब नहीं होता है तो बहुत सारी चीजें दिमाग में आती. हो जाएगा तो आकर के बोलोगे नहीं मैंने कुछ नहीं पढ़ा था, सिर्फ सर का नोट पढ़ा था. लेकिन नहीं होगा तो फिर उसी सर को, ठीक है, पैर से लटका दोगे उल्टा. तो इसीलिए ओके, गुड. तो और यहाँ पे नहीं होने वाले ज्यादा होते हैं, ये मैंने पिछली बार ही बताया था. ठीक है, तो लटकाने वाले ज्यादा हैं, सपोर्ट वाले कम. राइट, तो आगे बढ़ जाए. और इन चीजों का बुरा नहीं मानना है. सर ऐसा क्यों बार बार हमको बोलते रहते हो, नहीं होने वाले ज्यादा हैं. इसलिए बोलता हूं ताकि आप लोग होने वाला साइड जाइए, थोड़ा और फोकस होइए और एफर्ट डालिए. आगे बढ़ते हैं. लेट अस कम टू अर्थक्वेक्स नाउ. ओके, अर्थक्वेक्स, नेक्स्ट टॉपिक. सो when you talk of earthquakes, I hope you slightly remember when we are doing the interior of the earth. At that time we have slightly touched that topic of the hypocenter or the focus and the epicenter and the body waves. तो body waves तक याद है सबको, है ना, because वो फिर otherwise I have to tell the whole story. So can I start directly from there? Right, okay, thank you. So let me show you some diagrams and let us directly pick from there. This one, ऐसा कुछ diagram था, this one. And what did we understand in this? That first of all, what is an earthquake? We wrote there, है ना, earthquake is the sudden release of energy in the interior of the earth. Where interior? At some depth. What was the depth? 10 kilometers to up to 700 kilometers. कुछ ऐसा भी लिखा है शायद, अगर नहीं लिखवाया तो मैं अभी लिखवाऊंगा, don't worry. But up to a depth of, so up to your asthenosphere region, you can say that way. Though your asthenosphere as per NCERT is 400 kilometers, but when I told you about asthenosphere, there I asked you to write that please do write up to 700 also. Why? Because of this volcanic aspect. Because of this earthquake thing. So first thing we have to understand is that earthquakes take place either in the lithosphere region or maximum up to asthenosphere. Earthquakes do not originate in the mesosphere region. Okay. Now why do they take place? Earthquakes take place because of sudden release of energy. Why does that energy build up? Basically due to plate movements. Okay. So when the lithosphere is either breaking away or going side by side and causing friction, or it is subducting. When the lithosphere is subducting, that subducting lithosphere goes in the asthenosphere. Asthenosphere में ही जाता है ना. I hope everyone is, है ना. So when the lithosphere is subducting in the asthenosphere, it can go up to a depth of nearly 700 kilometers before it completely melts. So as it is going down, it can have different pressures working on it. Why? Because it is trying to sink into something denser. ठीक है, lithosphere was light, asthenosphere was dense, but this light thing is trying to press against that dense thing. ठीक है, due to gravity or because of the convection. So that builds up pressure in the which region? In that asthenosphere kind of region. So suppose this is your lithospheric plate and it is subducting in the asthenosphere, something like this, ऐसा करके जा रहा है नीचे. ठीक है, now this whole belt is asthenosphere, and in that this whole thing is going down. So as it goes down, it can build pressures at different places like this. यहाँ पे pressure हो सकता है, बीच में से if it cracks there also it can build pressure. So these are called as deep focus earthquakes. Focus means the place where the energy gets what? Released. The place where the energy is getting released or building up. That place is called as the focus. I hope you remember. So how deep can that focus be? The focus can be as deep as up to 700 kilometers. Right? And hence earthquakes can originate up to a depth of nearly 700 kilometers. The ones which are in the top region, we call them as shallow focus earthquakes. The ones which are the deepest, up to 700, 300 to 700 we say. Right? So they are called as deep focus earthquakes. Do we get it? Okay. So now coming back to the focus again. I'll dictate all that, don't worry. वो सब हम लिखेंगे अभी. बस अभी समझते जाइए. So this is your focus region, and from the focus what do I get? Sudden release of energy. That energy release travels in the form of waves. What do we call these waves as? Seismic waves. Right? And because they are created in the body, hence body seismic waves or seismic body waves, whatever you call. Okay? Where do they travel? In the body of the earth only, and then finally they touch the surface of the earth. Everywhere? Almost everywhere. Almost तो चलेगा ना, मतलब removing those shadow zones. ठीक है? Now where will be the intensity of the body wave maximum? At the epicenter. Why? Because it is traveling the minimum distance in the body, so minimum loss of energy. Simple. ठीक है? So epicenter is where? Vertically above the focus on the surface of the earth. So somewhere here you have that epicenter. ये दिख रहा होगा आपको इधर? Epicenter है. Now from here the real earthquake story starts. अभी तक ये सब हम body wave से energy ला रहे थे. ठीक है? But now everything will happen. ठीक है? So if I give you an example, whatever you have done till now is like throwing a stone in the lake. But the wave in the lake starts the moment the stone touches the water. है ना? सरफेस के ऊपर आपने ऐसा पत्थर फेंका, तो पत्थर आपके हाथ से छूटता ही तो पानी कांपना नहीं शुरू हो जाता, पत्थर आ रहा है. When the stone touches that water level, that's when a wave starts. That wave is like the earthquake. Clear hai? Okay. So here what is happening? The body wave touches at the epicenter. From there on that place, surface waves start. And those surface wave is something that we feel. Clear? So that is that surface wave is the thing which vibrates the surface in two ways. One like this, the second like this. Right? So the surface waves are, first thing, they are transverse waves. Right? Body wave जब हमने किया था तो दो टाइप का वेव किया था, longitudinal and transverse. What is the difference? I don't want technical definition. I need example. Longitudinal wave is like, have you seen a snail move on the surface? Snail को move करता देखा है, बिल्कुल पतला सा वो जो एक, or those fiber kind of this thing. They tend to contract their body and then they tend to expand their body. And that's how they move forward. देखा है ना? Earthworms, not snail, earthworms. I'm so sorry. Earthworms. So earthworms, they lie on the ground and then they tend to contract their body and then they expand. वैसा ही if you take a very long spring and if you want to create a wave in that, you just push at one end. The whole spring will contract and then it will expand. And that contraction expansion travels in the spring as a wave. That is called as a longitudinal wave. Okay, so the contraction and expansion is in the direction in which the wave is moving. Right? Whereas a transverse wave is like, आजकल वो बहुत फैशन में है, rope वो जिम के अंदर रोप लेकर के ऐसा ऐसा करते रहते हैं, ठीक है. सो व्हाट इज दैट? दैट्स अ ट्रांसवर्स वेव. वो जो आपका रोप को आप ऐसा झटका देते हैं, व्हेन यू गिव अ शॉक टू द रोप, अ वेव ट्रेवल्स इन दैट रोप, ठीक है. दैट इज लाइक अ transverse. But transverse waves can be of two type when you're talking on the surface. One, vertical transverse, like the water wave. Second, snake transverse. How do snakes move? They also move transverse, but they move horizontal transverse. Do you get it? Okay, so your surface waves are of two types. There are two surface waves, right? The L wave, which we call as the love wave, and the R wave, which we call as the relic wave. Right? Both are transverse, but one is vertical transverse, the other is. So basically, how do they move the ground? They move the ground two ways. One, they move the ground like this. Second, they move the ground like this. And both these shakings is something that we experience as the earthquake. That's your earthquake. Clear? Do we logically understand this? है ना? तो अब ये लिख लें थोड़ा थोड़ा. Right? Should we start and write? Good. So write down. That the seismic activity taking place in the asthenosphere or the lithosphere. Seismic activity taking place in the asthenosphere or the lithosphere leads to sudden release of body wave, from the focus or hypocenter, from the focus within bracket hypocenter, full stop. The focus can be at different depths. Comma, 0 to 70 kilometers. 0 to 70 kilometers. We call it as shallow focus earthquakes. 0 to 70 kilometers. We call it as, कहीं कहीं पे 10 to 70 लिखा होता है, but that is not 10 to 70, that is 0 to 70, right? 0 to 70 kilometers, it is shallow focus earthquakes. I'm saying 0 because even if a meteor hits the ground, right, that is 0 kilometers. It just touches on the surface. So that will create a shallow earthquake. Okay, that's why we write 0. So 0 to 70 kilometers, that is a shallow focus earthquake. 70 to 300 kilometers. 70 to 300 kilometers. It is an intermediate focus earthquake. 70 to 300 intermediate focus, and deeper than this, deeper than 700, it is, oh sorry, deeper than 300 up to 700. Deeper than 300 up to 700, it is deep focus. Deeper than 300 up to 700, it is deep focus earthquake. Okay, also. Next, when the body waves hit the epicenter, they generate surface waves, namely relic wave and love wave. Both are transverse. relic wave and love wave, both are transverse, but one is vertical transverse. Relic wave is vertical transverse, like water waves. The other one is love wave is horizontal transverse, like snake. The way snake moves on the ground. Okay, both of them are written on the board. Right, so this is how you get the relic wave vertical, water-like, and the love wave horizontal, snake-like. Clear? हाँ जी, हाँ बिल्कुल, दोनों साथ ही चलते हैं. Okay, so both of them are created on the surface of the earth together. These waves create the shaking of the ground that we feel as earthquake. These waves create the vertical horizontal shaking of the ground. These waves create the vertical horizontal shaking of the ground. Vertical horizontal shaking of the ground that we feel as earthquake. Okay, so this is it. This is your earthquake. Now, how all earthquakes are created? How earthquakes are created? How they are created, or causes of earthquakes. So earthquakes can be caused naturally or man-made. We'll write both. First naturally, then man-made. Earthquakes can be caused naturally or could be man-made. Earthquakes are created naturally or could be man-made. First, natural. So which are the natural earthquakes? सबसे पहला tectonic earthquakes, right? The first ones are tectonic earthquakes. Natural, first tectonic earthquakes, right? So tectonic earthquakes would mean where all will we get it? At divergent, convergent and transform boundaries as well as at mantle plumes. तो सब लिख दे, right? Tectonic earthquake means at convergent, divergent and transform boundaries. Divergent, convergent and transform boundaries as well as at mantle plumes. Okay. Then second, volcanic earthquakes. Volcanic. They are also tectonic but caused mainly due to volcanic eruption. Second, volcanic earthquakes which are part of tectonic only. Part of volcanic only but due to violent volcanic eruptions. Part of tectonic but due to violent volcanic eruptions. Violent मतलब कौन कौन सा eruption हो सकता है? You can have the stratovolcanoes, you can have the caldera cones, they can give you, or the ash and cinder one, right? So they can give you these volcanic earthquakes. Okay, then the third one. So these are the two. Now, so this is your tectonic part. Apart from this tectonic, volcanic, itna clear hai na? Matlab these are factual things. I'm just there isn't too much of concept in this. The third one is what we call as the landslide volcano earthquakes. Landslide, right? So large landslides can also create earthquakes. Large landslide caused earthquakes. This is the third type of earthquake. Large landslide caused earthquakes. Tectonic, volcanic, landslide. Now always keep in mind, landslide will not create a very large earthquake. Landslides will generally have a localized earthquake. So they will be experienced mostly in the local region. maybe up to 50 kilometer, maximum 100 kilometer, right? For that you need a very big landslide, but you will generally not get up to 100 also. 10, 15, 20, 30 kilometer, that's it, maximum, right? Whereas the volcanic ones can be large, and the biggest are the tectonic ones, where the plate movement, subduction related, right? They are experienced far away, up to 300, 400 kilometers, okay? Right? Maybe much more at times. You might have felt or read in newspapers that there was an earthquake in Afghanistan felt in, northern parts of India. So, matlab that is far away, but still you experience it. Is this okay? Right? Then the next natural one is the meteor hit earthquakes. Meteor, M-E-T-E-O-R. So when a meteorite hits the ground, meteorite, we call it as meteorite, M-E-T-E-O-R-I-T-E, पूरा लिखिए. When a meteorite hits the ground, M-E-T-E-O-R-I-T-E, when a meteorite hits the ground, and if it is of substantial size, if it is of substantial size, it can cause large earthquakes and tsunamis. It can cause large earthquakes or tsunamis. And also create meteorite craters. What is a crater? A depression in the ground. We have seen volcanic craters. This is the other way craters are created. So you can have a crater created by volcano. You can also have a crater created by a meteorite hit. Okay? Now here I want you to write one example. For example, the Chicxulub crater, write down this name from the board. The Chicxulub crater, around 65 million years before present. Chicxulub crater created around 65 million years before present in Mexico. Chicxulub crater created 65 million years before present in Mexico was due to a meteorite which caused a huge earthquake and tsunami on the earth. Huge earthquake and tsunami on the earth, causing around 75% biodiversity extinction. Causing around 75% biodiversity extinction on the earth. So thanks to this one big meteorite hitting the earth around 65 million years before present, that crater was created that created such a huge earthquake and tsunami that nearly 75% of population of any species on the earth was wiped out, including the dinosaurs. So one of the dinosaur extinction theory says this, right? It was because of this. So you can imagine the scale of that earthquake. Okay? So this is another way a natural. Basically the biggest earthquakes on the earth or tsunamis on the earth are created due to meteorites. They are not created due to tectonic activity also. Okay? Clear? Very good. So these are the natural ones. Okay? Now after this we come to man-made earthquakes. Man-made earthquakes. Man-made earthquakes. We also call them as anthropogenic earthquakes. Anthropogenic earthquakes. Anthro means human, right? So anthropogenic means the ones which are due to human beings, caused by human beings, right? So anthropogenic or earthquakes due to humans include mining activity. So what are the causes of man-made earthquakes? One is mining activity, mining of minerals, oil, gases, because when you are mining, you are basically creating hollows in the earth, right? Wherever you create a mine, you are creating a hollow, and that hollow might collapse onto itself if not properly mined. Okay, so when you're creating a mining hollow, you have to ensure that it is filled or it is made stable. If you do not make it stable, the whole thing might collapse. If it collapses, that will create a localized tremor or earthquake. Is that okay? So that is one. Second is also what you call as groundwater extraction, right? If you have excessive groundwater extraction, excessive groundwater extraction, that can also cause localized earthquakes. Right? Then nuclear explosions. And other large explosions like dynamite and all. Nuclear, dynamite or large bomb explosions. So nuclear explosion and other also. Nuclear and other. You can write both yahin pe. And other large explosions. Right, they create. Then the next one is what you call as dam related earthquakes. We also call them as reservoir induced earthquakes. Reservoir induced earthquakes. So dam related earthquakes also called as reservoir induced earthquakes. What is a dam related earthquake or a reservoir induced earthquake? Let us see. Suppose you have a mountain, and I would like you to draw this diagram also in your copy. Suppose you have a mountain, and in the mountain you have some water source like a river or a stream flowing. Right, now what do we generally do? We create dams to hold the water. Right, so construction is done and you might create a dam like this, aisa. Right, once you create a dam, the water tends to accumulate in this whole region. Right, now all this structure and this load is man-made. So if you see all this load, this is additional human induced load. Right, additional human induced load, because the strata or the ground is not made or it hasn't grown or developed to take up that load of that whole dam and all the water that you fill in that region. So gradually what happens is that pressure starts building in that region on the ground, and after maybe a decade or 2 decades, all that pressure might suddenly release. When it gets released, it will create a localized earthquake. We call this as reservoir induced seismicity. There is a name also for it, reservoir induced seismicity. Okay, so just draw this diagram. I'll keep it on the side. Once you are done, there's a dam in that. I haven't written, वो लिख देता हूँ. A reservoir dam, and we call it as RIS, reservoir induced seismicity. Excessive water extraction related. We don't have any internationally known or nationally known, but they might create localized tremors in the regions. Right, but Can we say that? Come again, that word that you are saying, integrated. Did you say integrated? Integrated? Okay. Integrated oceanic deep drills that we are doing, right? See, many of these deep drill exercises, there it will depend on for what purpose we are doing. Okay, for example, if we are doing it for mining in the oceans, we are mostly doing it for oil mining, right? They do create localized tremors, but that is mining related. That is not groundwater. Okay, right? And then many times we are also doing scientific research drills, like in the Kola Peninsula, Russia we have done, or even in the oceans we have done. So it will depend, but that's more of research or mining. And research ones don't create earthquake. Mining related can cause, because then you are extracting also. And we generally, to reduce the cost of extraction, we generally do not build the required, whatever structure is required to stabilize that zone. So we just leave it like that. That creates localized earthquakes. For the localized earthquakes due to oil, yeah. That's what I'm saying for the groundwater, because I think you asked me about the groundwater thing. Groundwater, we don't have any major examples, but we have ground tremors felt in regions where groundwater is extracted on large scale. Right, tremors. So tremors are something like they are just the initial, very small scale earthquake, you can say. But we do feel the way dynamite explosions can create. Right. For example, if you have a dynamite explosion, it can create localized tremors. A nuclear explosion will create a large this thing. So for nuclear ones, we have. Every time you do a major nuclear explosion, you have an earthquake felt. ठीक है? So, but for the dynamite one, जैसे अब आप पूछो सर dynamite का कोई example दो, तो मैं लिखवा नहीं सकता हूँ. ठीक है? Because वो होता रहता है. It's localized thing, right? So, do we get it? But for this, we have one major example. That is the Koyna Reservoir in India, Maharashtra. Right? So for this RIS thing, you can write one name: the Koyna Reservoir, Koyna Dam, Koyna. The Koyna Dam reservoir induced seismicity in Maharashtra. Koyna is in Maharashtra. Koyna Dam reservoir induced seismicity in Maharashtra. Alright. So that's it. These are the major causes of earthquakes. Clear? Now we come to measurement of earthquakes. Another PT type of question. They can ask you these questions, especially for mains also. How earthquakes are measured, what are the causes, etc. तो इसलिए थोड़ा लिख लेते हैं, right? So measurement of earthquakes. Measuring of earthquakes, right? So when we talk of measurement of earthquakes, it can be on two bases. One, what we feel. Second, what we measure. Right? What we feel. And second, what we measure. When we talk of what we feel, we call it as intensity based measurement. Intensity based measurement. Second, when we say what we measure, right, that is something called as the magnitude and amplitude based measure. So earthquake we can measure two ways: how we feel about it, and second, how much we have measured. ठीक है? Clear? So what is the difference between the two? The difference between the two is like somebody punching in your face and somebody punching a machine. You have those punching machines, have you seen? Where you go and punch and they will show you the score. कितना score आया. So there you compete amongst yourself, है ना? मैं एक घुसा मारा, आपका दोस्त ने भी मारा, है ना? सबने मिलके मारा और देखा किसका score ज़्यादा है. That is like measurement. Whereas this is something that you feel. है ना? कितना पढ़ा. ठीक है? पढ़ना पे feeling कैसा आया? जैसा पापा से थप्पड़ पड़ा या मम्मा से थप्पड़ पड़ा, है ना? My daughter says आप हाथ नहीं लगा सकते. हम लोग सोचते थे हम तो इतना बोलते तो दूसरा पड़ जाता. पहला तो पहले ही पढ़ चुका होता. ठीक है? दूसरा तक पढ़ सकता था. तो तो आजकल के बच्चे वो चाइल्ड हेल्पलाइन ने उनको ज़्यादा एक्टिविस्ट बना रखा है, ठीक है? तो ओके, सो बट आई होप यू अंडरस्टैंड वो पढ़ा का इंटेंसिटी है ना, तो पहला जब पढ़ता है तो ज़्यादा चोट लगती है, धीरे धीरे वी गेट यूज टू, है ना, अब तो पढ़ता ही रहता है. द डिफरेंस इज द सेम इन अर्थक्वेक्स ऑल्सो. जब कभी कभी पड़ता है तो तेज लगती है, जब अक्सर लगता रहता है तो लगती भी उतनी नहीं है. चलो आज का थप्पड़ कल के थप्पड़ से तो कम ही था. ठीक है, मैनेज हो जाएगा जैसा बोला किसी ने. ठीक है, सो द सेम थिंग हैपेंस विद अर्थक्वेक आल्सो. फॉर एग्जांपल, इफ यू लिव इन अ रीजन वेयर अर्थक्वेक्स कम वेरी रेयरली, then every earthquake can feel very strong. But if you are living in a region where earthquakes are regular, like Japan, सुबह भी आया, शाम भी आया, कल भी आया, परसों भी आया, तो फिर आप बोलते हो ठीक है, चलता है इतना तो. Do you get it? This is the difference between intensity, right? So when you say intensity, it's basically on the basis of how you feel. For example, let me make you understand, because these intensity-based measurement of earthquakes are not very scientific. They are not very scientific. Reason being, they are based on how much destruction they cause, right? It's not about how much energy has been released or how much shaking is there. It's based on the effect. इसका effect कितना था? Now, effect will completely depend on how much you are prepared to take that effect, right? If a region has prepared or made its construction in such a manner that despite of large amount of shaking, the buildings will not fall, like in Japan, so there the effect of the earthquake is very less. So for them, an earthquake of the same energy might have less intensity because their buildings are not falling. Whereas in, let us say, a place like peninsular India, where earthquakes don't generally come, right? So even the most of the houses in the village might fall down. Okay, because they are built that way. They were never built to withstand an earthquake. I hope you get it, right? Or a place like Delhi, right? Here buildings are not made to withstand earthquakes. In general, I'm telling you this, despite of the fact that this is an earthquake prone zone, but most of the buildings in Delhi are not constructed to withstand good earthquakes. हम यहाँ पे ज्यादातर पैसा टीवी और इसमें शो पानी में खर्चा करते हैं, ठीक है, क्योंकि गेस्ट तो रोज आएगा, अर्थक्वेक तो कभी कभार आता है. ठीक है, तो गेस्ट के लिए घर अच्छा बनना चाहिए. अर्थक्वेक तो जब आएगा तब देखेंगे, उसके समय तो सबका ही घर गिरा होगा. तो गेस्ट आएगा ही क्यों हमारे घर? ठीक है, सिंपल सा लॉजिक है. सो आई होप यू अंडरस्टैंड. ठीक है, सो दिस इज द डिफरेंस बिटवीन दिस इंटेंसिटी वन. सो शुड वी राइट? राइट, प्लीज राइट डाउन द इंटेंसिटी earthquakes, intensity based measurement of earthquakes, intensity based measurement of earthquakes which are based on, which are measuring, you write this way, which are measuring the effect of the earthquake, which are measuring the effect of the earthquake and hence not a very scientific, scale of measurement, not a very scientific scale of measurement, was the scale developed earlier, were the scales developed earlier. Okay, were the scales developed earlier. So intensity scales are older scales. They were developed earlier. They are non-scientific. They are based on the effect. Okay. So one of the oldest one is the Mercalli scale. Mercalli scale. That's an intensity scale. Please do write the name from the board. Mercalli scale. That was the first intensity scale that we had. And there's the second scale is the MSK scale. That's also an intensity scale. MSK. I'll write the full form of this. Medvedev-Sponhauer-Karnik scale. MSK scale. That's also an intensity scale, as you can see. So these two are intensity scales. They measure the effect of the earthquake. Okay. When we say MSK scale, why have I given you? Because for many of you, this must be a name that you are coming across for the first time. I've given you this because the earthquake, India earthquake prone diagram that you have in your NCERT is based on MSK scale. If you see the diagram, I think in your NCERT you will find at the bottom somewhere it is written based on MSK scale. Okay. So whenever you will see any India earthquake prone diagram, right? Earthquake prone regions, ऐसा एक diagram आपने देखा होगा, अक्सर होता है ना? So I think something like this is given in your NCERT also. Not exactly the same diagram. This is a colorful diagram. That's a black and white diagram, but it is something like this. Okay. Now this diagram of India is done by the government of India. They have marked the earthquake prone zones in India, right? On the basis of how much effect of the earthquake we can experience. They have given in terms of effect. What type of effect should you experience in these regions? Okay. So this is a MSK scale based classification of India, right? So for this MSK scale, I want you to write down 2-3 more lines, maybe 1 or 2 more lines. The MSK scale is a macro seismic. It's a macro seismic because they can ask you in prelims. It's a macro seismic intensity based scale, for marking big regions, into earthquake prone zones. Marking big regions into earthquake prone zones on the base, right? Earthquake prone zones. Good stuff. Both Mercalli and MSK scale. Both Mercalli and MSK scale have 12 levels. 12 levels. Where level 1 is the not felt. Level 1 means not felt. An earthquake that you don't even feel. Right? Where level 1 is the not felt earthquake, which we human beings don't generally feel. Right? Whereas level 2 is extreme. Level 2 nahi, 12. Level 12 means extreme earthquake. Level 12 means extreme earthquake. Extreme. Causing total damage of all man-made structures. Total damage of all man-made structures. And the ground seems to move like total damage of all man-made structure, and the ground seems to move like water wave. The ground seems to move like water wave. The way you see waves in the lake, same way the whole ground will seem to move like a wave. Okay, so that kind of an earthquake which you mostly see in these Hollywood movies. है ना, वो एंड ऑफ द वर्ल्ड टाइप मूवीज में दिखाते रहते हैं ना, पूरा जमीन ऐसा ऐसा हो गया, ठीक. सो दोस काइंड रियल में किसी ने भी नहीं देखा वैसा, बट दे हैव मेड अ स्केल फॉर द मैक्सिमम, राइट. फर्दर राइट डाउन, as per the MSK scale, India is divided. Write down about the India part. As per the MSK scale, India is divided into 4 zones. 4 zones. Zone 5, we start with the top one. 4 zones. Zone 5, first one is zone 5. Right? 4 zones are there, but the first zone itself is zone 5. We are starting with that. Zone 5, which is equivalent to the scale 9. Zone 5, which is equivalent to scale 9 of MSK. Scale level 9. So India zone 5 is MSK scale level 9, within bracket destructive. For MSK this is destructive level. Right, which regions in India are that earthquake prone zone 5? Which all? Can you see? वो red colored दिख रहा है, ठीक है? So please do write them, right? First, whole of all the 7 northeastern states, 7 northeastern states, the 7 northeastern states, then northern Bihar, around that Nepal-Bihar boundary, northern Bihar, then Uttarakhand, northern Uttarakhand, not whole of Uttarakhand, northern Uttarakhand, northern Uttarakhand, parts of northern Himachal Pradesh, parts of northern Himachal Pradesh, and southern Jammu Kashmir, southern Jammu Kashmir. Then next is the northern parts of Jammu Kashmir, northern parts. So not this one, I'm talking this one here. Northern parts of J&K, and then you come here, the Kutch Peninsula. The Kutch Peninsula. Okay, these are the 5 most earthquake prone zones of India. Alright? Then zone 4, which is generally surrounding the zone 5, zone 4, which is generally surrounding the zone 5, and this is MSK scale level 8, MSK scale level 8. Then zone 3, which is MSK 7, and lastly combined zone 2 and 1, combined zone 2 and 1. So we have combined the zone 2 and 1 as one zone now. That's why though we have 5, we say 5, but we have only 4 zones. Okay, the combined zone 2 and 1. Earlier it was 2 separate and 1 separate, but few years back we combined both, and then we have created one zone for that. Right? So combined zone 2 and 1, we call it as zone 2 only. Right? So the last one in the diagram is zone 2. There is no zone 1 you can see here. Okay? So combined zone 2 and 1, which is MSK 5 and 6. MSK 5 and 6. So zone 2 of India is basically MSK 5 and MSK 6, both put together, fairly strong and strong. वो दोनों मिला करके एक ही बना दिया इन्होंने. ठीक है? Good enough. Hopefully we understand what is this MSK. So this is your intensity base, right? But do write that regions which are well prepared, for seismic activities, such as countries like Japan, South Korea, Singapore, experience much lesser adverse effect. Regions which are well prepared for seismic activity like Japan, South Korea, Singapore experience much lesser adverse effect of earthquakes or bad effect of earthquake as compared to less prepared regions. as in many developing countries. Less prepared region as in many developing countries, which experience more destruction due to earthquakes. Now come to magnitude scale, the next one. Okay, so what we measure, right? So the second scale is on the basis of what we measure, right? What you call as magnitude or amplitude. Okay. So how do we measure an earthquake? We have to write under this, right? The second scale is on the basis of what we measure scientifically. The second scales are on the basis of what we measure scientifically. This is not what we feel, but how much we measure scientifically. The second set of scales are on the basis of what we measure scientifically using a seismograph. What we measure scientifically using a seismograph. So what does a seismograph look like? A seismograph looks like this, something like this, right? It is just like your ECG for your heart. देखा होगा आपने, है ना? So बहुत आप ECG तो सब नहीं देखा होगा ना? Those heart readings that we have, you know, where वो movies में भी दिखाता है, ऐसा ऐसा pulse चल रहा है, चलता चलता ऐसा constant हो गया, constant होते ही सब रोना शुरू कर देते हैं, हाँ बहुत सारा इमोशनल डायलॉग, कैसा जा सकते हो, ऑल दैट, भगवान, वेयर आर यू, एंड फिर वापस, ठीक है? तो वो मूवी में है और वो इंसान का है, यहाँ उल्टा होता है, राइट? यहाँ पे नॉर्मल इज कांस्टेंट, नो, राइट? सो बेसिकली देयर इज अ शीट मूविंग और देयर इज दिस डिस्प्ले ऑन विच यू विल हैव अ स्ट्रेट लाइन. दैट मीन्स नो earthquake. The moment you see a shaking, that's the earthquake. Right, so when the earthquake comes, what happens is the machine is so made that the pencil, if I talk in terms of that pencil and paper thing, the pencil can feel the shaking of the ground, but the paper doesn't. That's how it is made. So the paper will remain constant irrespective of earthquake, but just the pencil will shake. So if the earthquake is there, the pencil will make that reading on that paper, something like this, right? And this is basically what you call as, right? Depending on how you are measuring, there are different ways. So this is what you call as that shaking or the amplitude. This is the amplitude. This is not the magnitude. Right? So when you measure the amplitude of the wave. How wide is the wave? Right? So you measure that amplitude. Once we have measured the amplitude, we use that amplitude in a formula to calculate the magnitude. So the magnitude is calculated, the amplitude is measured. ठीक है, आया समझ में, right? So this one is the measurement. This is what you measure technically, and then you calculate, and you know it is something like the when you go to a shop, the shopkeeper measures the cloth and then it calculates the price, right? So the length of the cloth is like the amplitude, and the price of the cloth is like the calculated magnitude, something like that. Just to make you understand the difference between amplitude and magnitude. आया समझ में? So what do we measure? Amplitude is what we measure, and what do we calculate? And that magnitude is the scale. Okay, that's how you can say this is pricey cloth, that is cheaper cloth, something like that. So वैसे यहाँ पे बोल सकते हैं, this is a bigger earthquake, this is a smaller earthquake, something like that. Clear? Hopefully, right? So लिख लेते हैं ऐसे. The seismograph. I think you have already written वहाँ तक. It is used measuring a scientific device called a seismograph. वो लिख चुके हो? उसका नीचे लिखिए. The seismograph measures the amplitude of the wave. Amplitude of the wave within bracket, the shaking of the wave. The amplitude or the shaking, the vertical shaking of the wave. Right, vertical here means this vertical, seismograph वाला vertical. मतलब वो उसमें wave में vertical मत जाओ. Right, the vertical shaking of the seismograph diagram. Right, that's your amplitude. The vertical shaking of the seismograph diagram. वो लिख लीजिए, नहीं तो बाद में वो vertical मतलब कुछ और बन जाएगा दिमाग में. Right, full stop. Then the measured amplitude is used. The measured amplitude is used to calculate the magnitude of the earthquake. The measured amplitude is used to calculate the magnitude of the earthquake. Measured amplitude is used to calculate the magnitude of the earthquake using the given formula. As per the proposed scale. Right? So every proposed scale will have its own formula. Right? For example, there are two proposed scales. One is the Richter scale. Richter proposed one scale and he gave his own formula. There's another scale called as moment scale. So the moment scale gave its own formula. There are two formulas. One is the Richter formula, the other one is the moment formula. So two scales, two formulas. Clear? So depending on how much amplitude you have measured, then you put them. If you are putting it in the Richter scale, you get the Richter magnitude. If you put it in the moment scale, you get the moment magnitude. Is this okay? Now what is the difference between the two? I'll tell you, don't worry. But पहले इतना लिख लेते हैं, ठीक है? So then write down. The Richter scale is the older. The Richter scale is the older magnitude scale. Richter scale is the older magnitude scale. Having measurements up to 10 scale levels or magnitude level. Up to 10 scale level or magnitude level. Full stop. This is a logarithmic scale. Log scale. This is a logarithmic scale. Logarithmic. LOGRITHM, right? Logarithmic scale. What is a logarithmic scale? What is a normal scale? 1, 2, 3, 4. They are all different from each other by 1 unit. Okay. When you talk of a logarithmic scale, every one number, please, this is for the ones who don't have this background. जो science वाला है उनको तो पता ही है. So when you see a normal footer or scale, every 1 unit, 1 to 2, 2 to 3, 3 to 4 is 1 unit away from each other. It's the same distance. When you see a logarithmic scale, every 1 unit is as far as the base of that scale. Okay, so if I have a 10 base logarithmic scale, it means that 1 to 2 is 10 times, 2 to 3 another 10 times, 3 to 4 another 10 times. So 1 to 3 will be 10 into 10, 100 times. Right? 1 to 4 will be 10 into 10 into 10, 1000 times. Are you समझ में? Right? So if I make, for example, if I make a logarithmic scale of base 10 like this, and I'm showing 1, 2, 3, 4, 5, 6, and then let's say if I'm talking in terms of kilometers, so I've made a kilometer ka logarithmic scale. So if this is 1 kilometer, this will be 10 kilometers, this will be 100 kilometers, this will be 1000 kilometers, this will be 10,000 kilometers, and so on. Now why do I do this? I do this so as to show something as small as 1 kilometer to something as far as 10,000 kilometer on the same scale. Okay, for example, on this scale I can show your house here, right? And I can show Panipat here, and I can show, let us say Chennai here, right? And then I can show something like London here. ठीक है, और उसके भी आगे चले गए तो कुछ 2-4 बाद में हम मून भी दिखा लेंगे. सो आपका घर से लेकर के मून तक एक ही स्केल में दिखा दिया. You get it? That's why logarithmic scales are created, so that you can show a range of things on the same scale. Because if I have to show moon on this scale where I'm showing otherwise आपका घर, वो डायग्राम यहां से लेके विजन का दूसरा ऑफिस तक बन जाएगा, है ना? उतना लंबा लाइन बनाना पड़ेगा. आई होप यू अंडरस्टैंड. That's why we create logarithmic scale. So a logarithmic scale word will keep coming in the question. They can ask you this question and then they can ask you why is a logarithmic scale created. So one, they will ask it's a logarithmic scale. The second part of the statement could be logarithmic scales are created so that. Now this is not geography but you should know. Do we get it? ठीक है, तो अभी लिख लें. So what type of scale is this? It is the Richter scale and the moment scale. Both of them are logarithmic scales of base 10. उन दोनों का बेस 10 है, राइट? वो ई बेस नहीं है, लॉग ई बेस का भी होता है, राइट? जो आप नॉर्मल लॉग टेबल देखते हैं, राइट? वो अलग अलग बेस का आप बना सकते हो, राइट? सो दिस इज अ लॉग ऑफ बेस 10. ये भी पता होना चाहिए, राइट? सो द रिक्टर स्केल एंड द मोमेंट स्केल आर logarithmic scales of base 10, right? Showing the, what do they show? What do they represent? Showing the magnitude, showing the magnitude of the earthquake which is the, which shows, you write this way, which shows 1 and 2. We write 2 points here. 1, which shows 1, the amount of ground motion, on the base 10 scale, amount of ground motion on base 10 scale, right? And also the amount of energy released, which is this is for energy, which is nearly 31 times, for every one, for every one number increase, which is nearly 31 times for every one number increase in the magnitude . Now, what did we mean? Something like this. अभी ये देखिए. This is the magnitude scale. Let us say we have these numbers. So there is an earthquake which is magnitude 2 and there is an earthquake which is magnitude 3. Right? Suppose. So how much is the ground movement? The ground movement difference between 2 and 3 is 10 times. Right? So the one which is 2 and the one which is 3, the 3 one is 10 times more ground movement than 2. But how much is the energy released? Nearly 31 times. Actually the exact number is 10 to the power of 1.5. ये इसका वैल्यू है, राइट? 10 to the power of under root 3/2. ठीक है, उसका है ये एग्जैक्ट वैल्यू, which is approximately 31 to 32 times, right? So if I say, suppose a place experiences an earthquake of 6 and another place experiences an earthquake of 7. The 7 one, how much more ground shaking is there? 10 times. How much more energy was released? 31 times. This is what I want you to be very clear. This is the prelims question here. ठीक है, तो ये दोनों आप जैसा भी बना करके लिख करके जैसे भी चाहो, that's why I have shown you both. ठीक है, so if this is earthquake A and if this is earthquake B, then in terms of ground movement and in terms of energy released, this is the difference. 10 times in terms of ground movement and 31 times in terms of energy released. Nearly 31 to 32 times in terms of energy released. So the magnitude scale gives you both ground movement as well as energy released. ये दोनों ही हम यहां से निकाल सकते हैं. Right? So this is your magnitude scale. ये कितनों को नहीं समझ में आया? बहुत अच्छा, कोई बात नहीं, घबराना नहीं है. और कोई? 2, 3 और 4, 5. वेरी गुड. देखो आपने हाथ उठाया लीडर के जैसे, तो बाकी सब भी जनता खड़ी हो गई, इसीलिए घबराना नहीं है. ओके, क्या नहीं समझ में आया ये बताओ. अच्छा, लेट मी टेल यू दिस वे. Let us say you have I have a bomb in my hand. टेररिस्ट मत बोलना बस. और वो बॉम्ब को मैंने इधर ब्लास्ट कर दिया. ठीक है. Now you will experience two things there. One, the ground that it shakes, and second, if somebody is close, he can also experience the energy. And in terms of the heat and whatever, the blasting power. Every earthquake has these two energies. One, the ground that it shakes, and second, now ground shaking is something that you feel on the ground. The energy is the total amount of energy released to create that ground shaking. उतना ग्राउंड शेक करने के लिए आपको कुछ एनर्जी रिलीज करना पड़ेगा ना. आ रहा है समझ में? ठीक है. सो व्हेन आई से अ मैग्नीट्यूड स्केल, द मैग्नीट्यूड स्केल, व्हेन आई मेजर द ग्राउंड शेकिंग, फ्रॉम दैट ग्राउंड शेकिंग आई कैन से दैट फॉर शेकिंग सो मच ऑफ ग्राउंड, this much energy must have been released. This is something that I can calculate. So that's what your magnitude scale gives you, right? So for example, let us say you are standing at some place and ground shakes. So you say, okay, 1 centimeter ground shaking has taken place, right? So you call it as scale 1 blast. Then let us say the next time 10 centimeter ground shakes. So you call it as scale 2 blast, right? So this is the movement, and for doing that movement, how much energy was released? Let us say initially like 1 unit energy was released. For the 10 scale more movement, or sorry, 10 times more movement, you have to release nearly 31 to 32 times more energy. So that is something that you can calculate and tell that if the ground has shaken 10 times more, which means the amplitude is 10 times more, magnitude is 1 time more, energy release will be 31 times more. So this is what your magnitude scale tells you. अभी clear है थोड़ा? Sure? Good enough. So चलिए आगे बढ़ते हैं. So how many types of magnitude scales we have? We have written 2. One is Richter. The second one is, now why at all do we need a moment scale when we already have a Richter scale? वो लिखना है, right? So the Richter scale, once you have written this much, then come to the next thing. The Richter scale gives us correct measurement, correct calculation. Richter scale gives us correct calculation of the magnitude up to an earthquake, of magnitude 8. Up to an earthquake of magnitude 8. But for higher magnitude, the Richter scale readings are not accurate. Richter scale readings are not accurate, and hence the moment scale was developed for correctly calculating earthquakes of magnitude more than 8. earthquake of magnitude more than 8. Okay, so that's it. This is your whole earthquake story. We have written all about it. With this we come to the end of earthquake also. The next topic is tsunamis. Before that I'll give you a चेहरा आप लोग का बता रहा है ब्रेक चाहिए. So let us take a quick 10-minute break and then let us come to tsunamis. Okay. That's a calculation. But 10 किसी चीज का 1.5 पावर कैसे हो सकता है ये पूछ रहे हो या हाउ डिड वी गेट दिस स्पेसिफिक. दैट्स कैलकुलेशन इन दैट फॉर्मूला. वो देखना पड़ेगा आपको. एनर्जी कैलकुलेशन देखो मिल जाएगा. वो मैथ्स है. आई डोंट वांट टू गेट इनटू इट इन द क्लास. आफ्टर द क्लास डिस्कस करना हो तो आ जाना. बट नॉट हियर. सबको क्यों परेशान करना. ठीक है. सो ऑलराइट टेक अ क्विक ब्रेक 10 मिनट्स. 49 हो रहा है अभी. 59 तक आ जाओ. Okay. So there is a doubt by, as I said earlier, I think also Shikha. So when will latitude, longitude, etc. come up? That will come up when we start with the climate part of the story. Okay. So it's still a few classes away. What is written under energy released? क्या लिख दिया है? Yeah, 31 to 32 times, something like this. Energy released. So that's it. So now let us start with the next part of the story. अच्छा, we did not write about earthquake prone zones ना. वो नहीं लिखा है ना. Did we? Did we discuss the earthquake prone zones? नहीं. वो भी पहला वाला क्लास में कब किया था तो बताओ कौन कौन सा है. कर लिया है तो सर्कम पैसिफिक वो वॉल्केनोस किया था ना. अच्छा आपको अभी तक यही नहीं समझ में आया कि चल क्या रहा है क्लास में. सर वॉल्केनो कर लिया अर्थक्वेक भी हो गया सर. साथ साथ ही तो है भाई बहन. ठीक है. भाई बहन भी कभी हमेशा साथ साथ नहीं रहते. ठीक है. तो अर्थक्वेक और वॉल्केनोज मस्ट ऑल्सो शुड नॉट ऑलवेज रिमेन टुगेदर. ठीक है. सो वी हैव टू कम टू दैट टॉपिक ऑफ earthquake prone zones because there are some zones which are not volcano prone but they are earthquake prone. ठीक है. So we have to talk of that. And I think एक और factual सा चीज था which is the strongest measured earthquake ever on earth. It was done in 1960 by the US in a place called as Valdivia in Chile. So that had a magnitude of 9.5. That is the strongest earthquake ever measured on earth. If you want you can write that. Right, the strongest earthquake ever measured. The strongest earthquake ever measured was in 1960 in Chile, Chile, Chile as you call it. 1960 Chile at a place called as Valdivia, Valdivia. 1960 Chile, Valdivia, magnitude 9.5. Valdivia, Valdivia, magnitude 9.5. That is the largest earthquake or the strongest earthquake ever measured. ठीक है. Clear? Now earthquake prone zones. So this is the strongest earthquake ever measured. 9.5. Now earthquake prone zones. So which is the most earthquake prone zone on the earth? As you can see in this diagram, this is a slightly different diagram than the previous one. So they have shown you dots of the earthquake. So these red dots are the earthquake prone zones and the shade is the zone. These red dots are the earthquakes and the shading is the zone. So you can see one shaded region like this, I think reddish color, another one, this one, yellowish color. दिख रहा है? So those are the different zones. So we have to write about this, right? Earthquake prone zone. The biggest earthquake prone zone is the circum-Pacific belt. circum-Pacific belt, which experiences around which experiences around 70% 70% of all earthquakes, 70% of all earthquakes starting from south of Chile, extending up to New Zealand and Andaman Nicobar, the same region, right? Extending up to New Zealand and Andaman Nicobar. This is the same region as the volcano wala region, right? So here they overlap. Then the second most earthquake prone zone is the Himalayan Mediterranean belt. Second most earthquake prone zone is the Himalayan Mediterranean belt. Now Mediterranean you have seen in volcanoes, but Himalayans you have not written. वहाँ हमने Himalayan नहीं लिखा था. Why? Because Himalayan region is a continental collision region. In continental collision you don't get volcanoes. What is the region? Himalayan Mediterranean region, right? How many earthquakes come here? Nearly 20% of all the global earthquakes come here. So 70% in circum-Pacific, 20% in Himalayan Mediterranean region, 20% of all earthquakes. So this region gets 20% of all earthquakes. Which zone is unique here? The Himalayan region. The Himalayan alpine region is unique. Why? Because from Himalayas up to Alpines, you don't get any volcanoes. In Mediterranean you get volcanoes, in Vesuvius and Etna, but you don't get them in the Alps. You don't get it in the Himalayas. You don't get the volcanoes in Hindu Kush, Trans Himalayas. वहाँ पे volcano नहीं होता है, right? Arakan Yoma, Pegu Yoma, ये सब mountains हमने किए हैं. इनमें we don't get volcanoes. So if you want, you can write here the Himalayan mountains. Here the Himalayan mountains, Arakan Yoma, Pegu Yoma, Trans Himalaya, Arakan Yoma, Pegu Yoma, Trans Himalayas, Hindu Kush, and the Alp mountains, Alp mountains don't have volcanoes. And only have earthquakes. Don't have volcanoes and only have earthquakes because of continental collision related formation. Because of continental collision related formation. ठीक है? The remaining, next line, the remaining 10% earthquakes, 90 तो आप लिख चुके हो, 70 plus 20, right? So the remaining 10% earthquakes take place in different regions and around East African Rift Valley, Caribbean, Mid-Atlantic region, and other regions of the world, and some other regions of the world. Okay, that's it. Now put the subheading tsunami. Can we say that we cannot measure? Can we say that we cannot measure horizontal wave? मतलब you mean to say horizontal transform waves? ये वाला जो लव वेव्स हमने लिखा वो हम दोनों करते हैं. जो आपका मशीन है वो दोनों वेव्स मेजर करता है, वर्टिकल और हॉरिजॉन्टल. सरफेस वेव्स जो है, सरफेस वेव है ना, हमारा जो अर्थक्वेक किससे क्रिएट हुआ है? सरफेस वेव से. तो सरफेस वेव दो टाइप का है, द एल वेव एंड द आर वेव. द सीस्मोग्राफ मेजर्स बोथ. ठीक है, राइट. इट ऑल्सो मेजर्स द पी वेव एंड एस वेव. वो बॉडी वेव भी मेजर करता है. तो सबसे पहला उसका मूवमेंट बॉडी वेव से ही होता है, पी वेव से. बट दैट पी वेव मूवमेंट इज वेरी लेस. It measures, though it doesn't cause earthquake, but the seismograph is a machine which is able to measure that also. आजकल आपने देखा होगा, आप लोग का बहुत सारे घरों में you have that oximeter. देखा है? हाँ, उसमें 98, 94 का नीचे गया तो हॉस्पिटल. ठीक है, तो वो 94, 98 के सिवाय और भी बहुत सारा रीडिंग दिखाता है. आपका पल्स भी दिखाता है. हाँ, तो उसी तरह से सीस्मोग्राफ भी और भी रीडिंग्स दिखाता है, राइट. बट द मेन थिंग दैट वी यूज इज फॉर द सरफेस वेव्स. ओके. The ones originating from outside. Is there a difference? That yes, you can say there is a difference. The difference is in terms of, for example, when you say the shallow focus earthquake and the deep focus earthquake. What is the major difference? The deep focus ones, because of the geometry of the wave, are felt up to farther distances, right? The closer you are to the surface, more energy is required for the wave to be felt farther. ठीक है, if the same amount of energy is there, right? उसका एक simple सा logic है. Suppose this is the surface of the earth. Now there's a focus here, there's a focus here, there's a focus here. This one you can experience only up to this region. This one you can experience up to wider region. And the deeper you go, the wider you can experience. ठीक है, but इतना deep में जाना नहीं है हमें, ज़रूरत नहीं है. That's why I didn't cover. Right? हाँ जी. How a mantle plume is related to a volcano? सडन मान लो कहीं वॉल्केनिक इरप्शन हुआ और सपोज थोड़ा सा एक्सप्लोजिव हुआ तो वो वहां पे एक अर्थक्वेक क्रिएट कर देगा. ठीक है, एनी अदर डाउट? कोई वर्ड मिस हुआ है क्या आप लोगों का? कौन सा? वाल्डिविया हो गया, वही था. ठीक है, अभी क्लियर है? नथिंग एल्स? गुड, आगे बढ़े. Okay, so let us come to tsunami. What is a tsunami wave? Most of you have. Acha, when you talk of ocean, there are 2-3 types of movement in the ocean water that you come to hear about, and I don't know how many of you are clear about all the three. One is a normal coastal wave, right? The wave which you normally get when you are standing at the ocean coast. Okay, so the water will come, hit you and then go back, and something like this you also experience when you are standing on the coast, on the side of the banks of the river or on the edge of a lake. तो वहाँ पे भी पानी आता है ना, पानी आएगा, it will hit you and go back. That is a normal wave. In the oceans you also have something called as tides. We'll talk of tides later when we do the ocean wala part. And then there is something called as the tsunami wave. Now tsunami wave is a very big wave. It is like a wave, but it is a very big wave, right? So normal wave might just come and hit your feet. Tsunami wave will come and hit the house. ठीक है, तो ये difference है दोनों में, right? तो वो थोड़ा ज़्यादा बड़ा wave है, right? And it is more destructive. So we have to understand how a tsunami wave is created, right? Is this okay? Because most of you have not seen tsunami wave, but you might have only heard about it. So we have to just talk of that. Right, and then there is something also called as the surge, which is created due to what you call a storm surge, which is created due to cyclones on the coast. Storm surge is also like, it is a storm surge is a phenomena which is between tsunami and normal wave. So it is a middle thing. It is destructive, but it is not as destructive as tsunami, right? So storm surge we'll talk in cyclones, tide we'll talk in oceans. अभी हम सिर्फ सुनामी का बात कर रहे हैं, ठीक है? So there are different things. You should first of all be knowing there are different things, and then we'll take them one by one, ठीक है? So when you talk of a tsunami wave, the word tsunami is a Japanese word. I think आपने अपने NCERT में कहीं ना कहीं पढ़ा होगा, right? So it is made up of two words, TSU, su, and NAMI, Nami. Su means harbor and Nami means wave. Hence tsunami, simply the name means harbor waves. What is a harbor in that case? Harbor क्या होता है पहला ये भी पता होना चाहिए, ठीक है? So that harbor is a place where ships can come to the land, not on the land but next to the land, which means it is deep enough, right? So wherever you have slightly depth in the this thing, you know, on the coast, when you go to the coast and a ship can just stand next to you, you are at a harbor, right? And where the sand is flat and you can walk into the sea, that is a beach or a coast, normal coast. So coast can be a beach coast or it can be a harbor coast, ठीक है? So where the ship is standing next to you, harbor coast, and where you can walk towards the water and keep walking, that becomes the beach kind of a coast. Is this clear? So beach coast will be gentle and harbor coast will be steeper coast, right? So tsunami wave is a harbor wave. That's the name. But is it a right name? No, it's a wrong name. Why? Because when we say harbor wave, we mean wave which are created at the harbor. But tsunami is not created at the harbor. It only hits at the harbor, therefore you call it as a harbor wave, right? But it is not created at harbor. So therefore calling it as harbor wave will be wrong, people. It is like calling the Britishers as sea people because they came from the sea. ठीक है? They were not sea people, they were British people. They came from Britain, right? So same ways calling tsunami wave as a harbor wave is wrong because it is not created at the harbor. आया समझ में? Clear? So then how is the tsunami created? This is what we have to understand. ठीक है? Okay. So ये देखिए, this is a diagram, slightly big region it is trying to show you. It is trying to show you the ocean floor, and this is basically something like the coast, and these are ये छोटा छोटा tree है, right? So I hope you can make out the scale that they are trying to show you. So this is the beach kind of a region with trees, and this is the wave. So normally if you are standing there, maybe आप वो tree का भी 1/4 हो गए, तो दिखाना थोड़ा मुश्किल है इस डायग्राम में, ठीक है? इतना छोटा, and then just imagine the scale of the normal wave, and then imagine ये कितना बड़ा wave है, right? This is almost 3 or 4 times taller than the tree itself. Can you see in this diagram? दिख रहा है? ये दिख रहा है ना? देखो वो बेचारा पेड़ तो बह ही गया 2-4, ठीक है? तो अगर आप उस पेड़ के ऊपर लटक के बचने का सोच रहे हैं तो वो भी चांस कम है, राइट? सो दिस इज द स्केल. सो नाउ हाउ इज द सुनामी क्रिएटेड? प्लीज सी. मे बी थोड़ा लिख भी लेते हैं साथ साथ, राइट? सो वेर यू हैव पुट दैट हेडिंग सुनामी, यू कैन राइट डाउन सुनामी वेव्स. Tsunami waves are large. Tsunami waves are large oceanic waves, and they are only in the ocean. They are not created in sea or lakes, right? These are large oceanic waves hitting the coast, and are so huge that they cause large scale destruction. They cause large scale destruction due to their enormous energy. Large scale destruction due to their enormous energy. Full stop. The name tsunami means literally means harbor waves which is a Japanese term, but is a misnomer. 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 Misnomer means wrongly named. Okay, misnomer. Because misnomer, wrongly named, because tsunamis are not created at the harbor. Tsunamis are not created at the harbor, rather created in deep ocean. Full stop. Right? Next paragraph. Tsunamis are generated when huge amount of sudden release of energy. Huge amount of sudden release of energy takes place within bracket equivalent to huge amount of sudden release of energy takes place within bracket equivalent to 6.5 or more magnitude earthquake. This much energy should be released, equivalent to 6.5 or more magnitude, right? 6.5 or more magnitude earthquake equivalent energy. This much energy should be released. Okay, so 6.5 magnitude earthquake or more, this much energy, right, should be released. Then only a tsunami will happen. Clear? Also, the cause of tsunami. So what could be the possible causes which can release so much energy? That's what we are writing. Okay? Cause of tsunami, generally earthquakes, but not always. Generally earthquakes, but could also be explosive volcanic eruptions. Huge underwater landslides. Nuclear explosions, underwater nuclear explosions, or meteorite hits, large meteorite hits. Any of them can release the energy. Okay, but mostly we get it from earthquakes. Is this okay? Good. Now, what happens in that sequence? Let us see. Now, this is where I would like you to focus, and you have to draw this diagram also in your copy, but I don't want you to draw 3D kind of a diagram. Utna banana bhi nahi hai, na exam mein try karna hai. You have to draw only this wave, right? Something like this. Don't draw the upper part, right? So something like this wave, which I have tried to show here, and the ocean floor, right? So what we are trying to show is that near the coast, where the water is hitting the land, right? This is the coast and this is the deep ocean. Right? Deep ocean. ऐसा. ठीक है? ऐसा सा diagram आपको बनाना है. But for explaining, I'll use that upper diagram so that 3D में you can imagine easily. Okay? But for the exam, try to draw something simple. Always keep in mind, in the exam you should never try to draw a diagram which will take more than a minute. Okay? So you have to do the simplification at home. Any diagram which is taking more than 1 minute, you should simplify it at home. beforehand if you want to draw it in the exam. क्योंकि if the diagram is taking more than a minute, you will never draw it in the exam. You will be under so much pressure लिखने का कि वहां पे आपको इतना टाइम नहीं होगा, आप बोलोगे छोड़ो यार डायग्राम, राइट? सो ऑलवेज ट्राई टू ड्रॉ सिंपल डायग्राम्स, एंड ड्राइंग टू ब्यूटीफुल डायग्राम्स एग्जाम में ऐसा नहीं है, वो आपको कोई आर्ट वर्क के लिए नंबर नहीं देने वाले, राइट? उसके लिए वो बोलेंगे आर्ट क्लास ज्वाइन करो, आईएएस बनने का जरूरत नहीं है, राइट? आपको सिंपल डायग्राम्स दिखाना है, बिल्कुल सिंपल, एज मिनिमम पॉसिबल, एंड इट शुड जस्ट बी एक्सप्लेनिंग द कॉन्सेप्ट, ठीक है? सो नाउ हैव यू ड्रॉन, राइट? द डेप्थ्स एंड ऑल आई वुड लाइक यू टू राइट डाउन, और ये नंबर्स भी लिख लो, एंड देन आई विल एक्सप्लेन यू. आई थिंक राइट, वो सी लेवल मेरे को ऐसा ब्लू कलर में लिखना है इसमें, ठीक है? सो दैट ब्लूइश लाइन इज द सी लेवल, ओके? वो थोड़ा ऊपर वाला डायग्राम में अलग है, सो जस्ट ड्रॉ लाइक दैट, सी लेवल. Okay, done. How many still drawing? हो गया? Good. So now please see and try to understand. So what is happening is, in the deep ocean somewhere, let us say this is the hypocenter or epicenter, whatever, ठीक है? So from this, at this place the energy comes, hits, and once this energy, so at this place, once the energy is released from this place, what will happen is that that energy tends to create some displacement in the water also, right? It displaces the water, one, and secondly, that energy might travel in the water. We call it as T waves. So wherever that earthquake is generated in the deep ocean, T waves are created, right? And they travel in the water. जैसा ये दिख रहा है आपको. When they travel in the water, you can see these waves gradually becoming bigger, and there is huge amount of energy in these waves, right? So they are very high amount of energy, right? So these waves keep traveling and they keep becoming bigger and bigger, and by the time they reach the top of the ocean, the average depth of the ocean, as you can see here, is shown something like 5 kilometers, 5.5 kilometers. So by the time these waves reach the ocean top, the surface of the ocean, the waves have become very big, right? The circumference of the wave tends to become very big, and they have very high energy. So basically what is happening is, see here, the wave height, for example, if I draw the wave height in a finer, something like this, the height of the wave would be something like 3 to 5 feet. The width of the wave from one depression to the other depression could be as wide as, let us say, it can be as wide as 100 kilometers. So the wave tends to become wide, and the height is around, the higher part of the wave would be something like 3 to 5 feet. The third characteristic of the wave is the speed. These waves have speeds of up to 800 kilometers per hour or more. That is like the jet speed, right? So they travel very fast. Okay, but though they travel very fast, but they are so big. कितना बड़ा wave है? 100 kilometer. And how high? 3 to 5 feet. So just imagine a curvature of that size moving fast, right, in terms of wave. And when the wave is moving, always keep in mind, water is not moving. Wave and water are two different movements. Wave के साथ पानी नहीं जा रहा होता है. This is something new to many of you. Again, I know. When the wave is moving, the water on the top is not moving at a speed of 800 kilometers. Otherwise, कुछ ship wave का इंजन ऑन करने की जरूरत ही नहीं है. ठीक है, एक सुनामी वेव पकड़ो, 1 घंटा में 800 किलोमीटर. पानी तो जा ही रहा है, ठीक है ना? So when the wave is traveling, how do waves travel? Waves do oscillatory motion and pass on the energy, because that's an energy wave, it's not a water wave. ठीक है? So यहाँ पे oscillation होता रहता है, ऐसा ऐसा. The particles of water will keep moving circular, right? They will move circular and they will pass on the energy to the next particle, and that energy thing will tend to move at that speed, right? Why? Because there is no friction from below. So वहाँ पे सिर्फ water का energy move कर रहा है. So basically the water will go up and then go down, right? And the whole wave energy will travel at a speed of 800 kilometers, right? And how much wide is this? 100. So in 1 hour, how many waves will cross? 800 and 100 kilometers. How many waves? 8 waves. You get it? So in 1 hour, only 8 waves will pass you. And how high? 3 to 5 feet. So अगर आप कहीं पे भी हैं और आपका नीचे से 8 waves in 1 hour go and they take you high only by 8 feet, 4 feet or 3 feet, and then they bring you down gradually, will you realize that there is a wave going below me at a speed of 100 km per hour, 800 km per hour? No. Why? Because the wave is so big, right? It is like moving, rotating with the earth. The earth is rotating. It's rotating at very high speed, 1700 km per hour. But do you realize? You don't realize. Why? Because it is so big. You don't even realize the curvature of the earth. है ना? आपको कभी भी अर्थ का ऐसा राउंड सरफेस तो पता नहीं लगता है. यू ऑलवेज फील यू आर ऑन अ फ्लैट सरफेस एंड यू आर स्टेबल. वहां बैठ के योगा कर रहे होते हो और अर्थ बेचारा रोटेट कर रहा है 1700 किलोमीटर पर आवर पे. राइट? सो दिस इज व्हाट स्केल डज. इफ द स्केल इज वेरी बिग यू कांट रियलाइज इट. ठीक है? सो द सेम थिंग हैपेंस हियर दैट द वेव. सो हाउ मेनी वेव्स? 8 waves in 1 hour, taking you up by only 3 to 5 feet. Because of this, in the deep ocean, if there is a ship somewhere there, that ship will never realize that there is a tsunami wave in the water below it. This is why detecting tsunami waves in deep ocean is very difficult. In the open ocean, if the ship is far away from the coast, they can never detect it. And that's why we don't get alarms from the ships. Alright, so do we get it? Clear? So what did we get? This is a very high energy thing, traveling at a speed, very high speed, and this thing. So basically what is, in what form is the energy here? If I ask you in terms of the energies that you understand. Kinetic energy, potential energy, सब समझते हो ना? इतना तो पता ही होगा. What was kinetic energy? Energy of motion. What was potential energy? Energy of height. दो ही एनर्जी होता है, या तो मोशन का मतलब इस टाइप में. सो वन इज द मोशन एनर्जी. सो व्हाट इज द एनर्जी हियर? एनर्जी ऑफ मोशन. वी विल राइट इट लाइक दिस इन द आंसर, राइट? व्हेन वी विल बी राइटिंग, वी विल राइट इन द डीप ओशन. अभी नहीं लिखवा रहा हूं, आई एम जस्ट टेलिंग यू. सो इन द डीप ओशन ऑन द सरफेस द वेव्स हैव एनर्जी ऑफ मोशन. उसको हम काइनेटिक एनर्जी. व्हाई? बिकॉज देयर इज नो फ्रिक्शन टू इट. वाटर गिव्स वेरी लेस फ्रिक्शन. That's why large ships easily move on water. ठीक है? So water gives very less. आप भी मतलब boat या कोई भी चीज, if you try to push it on water, once you have pushed it, it will go slightly far because the friction is very less. And here the depth is also too much, so the friction from the surface is not there for this part. Now gradually what happens is, अब यहाँ से देखते जाइए आगे क्या हुआ. As these waves keep coming close to the coast, the depth of the ocean goes on decreasing. Can you see? So from 5,000 meters, it has come down to 900 meters and then gradually 20 meters. Thanks to this, the surface friction from the ground goes on increasing. And the wave starts feeling that friction. Right? When the wave starts feeling that friction, its speed decreases. Right? It is something like, I'll give you an example that will help you understand. You can see the floor on which you are sitting. It is such a smooth floor. If I take a bucket of water and I throw on this floor, that water will move very fast. ठीक है ना? But let us say at some distance I put, gravel. Right? ऐसा टूटा हुआ पत्थर, बहुत सारा टूटा हुआ पत्थर, if I spread there, and that water goes and hits that stone or those bulk of stone on the ground, what will happen to that water? Will it keep moving that fast? No. It will slow down and accumulate and tend to rise. Is this imaginable? The same thing on a large scale is happening in the ocean. ठीक है? In the deep ocean, friction is very less, so it is like moving on a smooth surface. So the water keeps moving fast, right? That energy wave keeps moving fast. Whereas when the energy wave comes across shallow ocean, there the friction from the surface increases, the wave becomes shortened and it tends to accumulate. So basically its kinetic energy gradually turns into height. The energy of speed gradually turns into energy of height. आ रहे समझ में? Right? It is just like stones के साथ अगर आपने पानी फेंका तो वहां पे जाके it will accumulate and rise. ठीक है? So you can see these waves are becoming shorter because of friction. As they become shorter, their height, their curvature goes on increasing. Right? And by the time it reaches here, the height of the wave is almost half of its diameter. Right? Or equivalent to its radius, which is something like 30 to 100 feet. It can go as high as 100 feet. ठीक है? So that is the height. 100 feet मतलब 30 मतलब approximately the wave width might be reduced. Okay, and this water accumulation will go as high as from 3 to 5 feet. It will rise up to 100 feet. And that 100 feet water is moving at what speed? The speed is also pretty much reduced. 800 jet speed से मोटरसाइकिल पे आ गया बेचारा 50 किलोमीटर. ठीक है, but 50 kilometer is also motorcycle. You can't chase a motorcycle, right? So that is very slow, but it is not slow for human beings, because human beings, even if they run, even if you are Usain Bolt, right, तो भी इतना speed touch नहीं कर पाओगे. That too on sand, without shoes. है ना? कोई sand के ऊपर तो वो PT shoes पहन के जाता नहीं है, तो वहां पे wave से बच के भागना will be difficult. This is why you can't escape a slow tsunami wave on the coast. ठीक है? Do we get it? So what is the height? 30 to 100 feet. What is the speed? 50 kilometers. What is the width? Much reduced. Right? So basically what has happened is the energy of movement here has turned into energy of height due to shallowing of the ocean and the friction from the below. ठीक है? This is what creates the tsunami wave ultimately. All right? जिसको नहीं समझ में आया हाथ थोड़ा सा खड़ा कर दीजिए. और आपका हाथ दिख गया मुझे. और that's it. Online people, अगर एक ही है तो फिर क्लास के बाद समझाऊंगा. अभी भी चांस है और हाथ खड़ा कर दो. Sir, I didn't understand the part about kinetic energy transform into height. Kinetic energy is, that's why I'm saying. अच्छा ठीक है, आपको मूवी का हिसाब से समझाते हैं. You must have seen in movies car going like this at very high speed and then all of a sudden it comes across some friction and the car rises like this. ऐसा होके गोल गोल घूम के तो जो कार ऐसा जा रहा था वो all of a sudden height कैसे ले लिया? Because it has too much of speed, energy. So that energy tends to throw it up. Because of that friction from the ground, it just rises, lifts. ऐसा 3-4 बार topple करेगा. ठीक है? So that smooth car movement speed has turned into toppling heights. Same ways, Subho day. I hope now it is clear. Got clear, clear. और क्या है? ठीक है, आप ही का डाउट है बस. अभी क्लियर हुआ कुछ? नहीं. क्या क्लियर नहीं है बताओ. मुझे पता है 2-4 और को भी क्लियर नहीं है, लेकिन वो अभी हाथ नहीं खड़ा करे. थोड़ी देर पहले ही तो किया था. सर सोचेंगे डफर है. इतना टाइम नहीं है मेरे पास सोचने का. जल्दी से हाथ खड़ा करो, बताओ. यस, what part is not clear? Tell me. The friction part from the surface. Okay. I don't know whether you have felt this. Have you? आपने swimming किया है? No sir. तभी मैं बोल नहीं रहा था. If you swim in deep water, swimming is easier. Right? If you try, but for that you should know swimming. You know, ऐसा नहीं है कि आता नहीं है, but sir told deep water swimming is easier, तो मैं उधर ही कूदूंगा. ठीक है? If you know swimming, swimming is easier in deep water, but in shallower water it's not very easy. Why? Because you get friction from the bottom, because the water doesn't move with you. right? Basically water has, all I'm trying to say here is water has very less friction as compared to hard surface. ठीक है? So when something is moving in deep water, the whole friction in that region is very less, right? So for energy waves also, the friction in deep ocean is very less. ठीक है? Because friction is very less, movement can be faster, like a glass of water thrown on a very smooth surface. Whereas as the ocean becomes shallower, the friction to the water and the energy wave movement becomes high. ठीक है? क्योंकि पानी कम हो गया and you are coming close to the land. ठीक है? So because of that the friction becomes higher, and that example I gave, in the end if I keep bigger stones या छोटा छोटा पत्थर का टुकड़ा भी रख देंगे, so that water will hit, and if it will try to cross those stones it will find more friction, so it can't move so smooth, it will rather tend to accumulate and rise, wave के जैसा वही हो रहा है. ठीक है? क्लियर? वेरी गुड. सो होपफुली अभी सबको क्लियर है, लिख लें. यस? हाँ, आप लोग का ना ये कन्विंसिंग यस नहीं है अभी भी नहीं, मतलब यार ऐसा भी नहीं, क्रिकेट मैच थोड़ी चल रहा है. वेल डन ऐसा थोड़ी चालू हो जाना है. हाँ जी, पक्का? मतलब क्या थके वके वो हो, क्या हुआ है? अच्छा ठीक है, लिख लो. So what is the last line that I have dictated? आप ही बोलिए, आप सबसे फ्रंट में. यस. Okay, very good. So the causes we have written, right? Now, the formation of tsunami wave. Formation. So formation of tsunami waves. Write down. When sudden energy is released, in deep ocean floor, sudden energy is released in deep ocean floor, far from the coast, comma, it leads to creation of waves in the ocean water, as shown. These waves I'm talking of, these ones, ऐसा वाला. ठीक है? So if you want to draw, you can draw somehow in your diagram also. ऐसा these waves you are talking. Okay? Full stop. Generated in the deep ocean, as these waves reach the surface, of the ocean, they become wide enough within bracket up to 100 kilometer wide, and hence not high enough as they get flattened. Not high enough as they get flattened. Not high enough as they get flattened. So how much is the height within bracket? 3 to 5 feet. 3 to 5 feet high than mean sea level. Right? 3 to 5 feet high than the mean sea level. But because of high energy released, and extremely low friction, high energy released and extremely low friction due to deep ocean, extremely low friction due to deep ocean. The waves and extremely high speed due to deep oceans. I think I said extremely low friction due to deep ocean. ऐसा कुछ बोला ना, extremely low friction due to deep ocean. They tend to take very high speeds. Tend to take very high speeds of the energy waves, of these energy waves, within bracket more than 800 kilometer per hour. Very high speeds of these energy waves, within bracket more than 800 kilometers per hour. Okay, good stuff. Now just imagine you are at this point, and one side you have the coast, the other side you have open ocean. So what will happen is the wave from this side can travel in both directions. One part can go this way, another part can go toward the open ocean. The one which is traveling toward open ocean, will it slow down? The one which is traveling toward, let us say on the other side, this side, let us say there is open ocean. Will it slow down? Huh? What was slowing down the wave? The friction. But this side it has open ocean. It's not having a coast. So will it slow down? So this side the wave might keep traveling like that, and until it reaches some land, it will not slow down. Right? But on the other side, this side, it is getting shallower. आ रहे समझ में मैं क्या बोल रहा हूँ? मतलब in this diagram, let me scale it down and show you. ऐसा. ठीक है, suppose ऐसा ही है, right? And so see, and this is where the wave was generated. ऐसा. So if the wave was generated this side, and this side, one part of the wave will go this side, the other will go that side. But here the ocean is pretty deep, up to a very far distance. So the wave will keep traveling like this. Okay, the tsunami wave will continue to travel like this, like a long wave, without being much traced. Right? Whereas when it comes closer on the other side, where the land is getting shallower, the deep ocean is getting shallower, there the wave will become bigger. So here you will not realize, if there is some ship here, will it realize there is a tsunami? No, until unless it reaches the other coast. Right? Once it start reaching the other coast, that's where the wave will again become steeper. ऐसा. ठीक है? But in the open ocean, you will not realize. That's what I'm trying to say. ठीक है? So I want you to note this down in your copy also. Right? So write down the part of the wave, the part of this wave, the part of this wave traveling towards open ocean, the part of this wave traveling towards open ocean will continue to move at high speed and low height till it reaches the coast on the other side. Till it reaches near, not exactly near, you write till it reaches near the coast on the other side. Till it reaches near the coast on the other side. Hence it remains mostly undetected. Hence it remains mostly undetected over the deep open oceans. Over the deep open oceans. Okay. Full stop. Next paragraph. The part of the wave moving towards the coast tends to experience higher surface friction from the gradually shallowing ocean floor hence the waves become shorter their height start to increase wave becomes shorter, their height starts to increase and their speed tends to, what should happen to the speed? Decrease, right? Decrease. The speed tends to decrease. All right. Also, by the time it reaches the coast, where the depth is less than 20 meters, comma, the speed might reduce to up to 50 kilometers per hour. The height might increase 30 to 100 feet within bracket. The speed of movement, the energy of movement turning into energy of height. वो kinetic to potential को हम ऐसा लिख रहे हैं. The energy of movement, that is kinetic energy, turning into energy of height, potential energy. I don't want you people to write too much of science in your geography answers. ठीक है? तो कम से कम साइंस यूज करना है. जैसा अभी किसी ने थोड़ी देर पहले पूछा था, सर वो रिक्टर स्केल का फॉर्मूला लिखवा दो. आपका क्लास में नहीं, ऑनलाइन था वो क्वेश्चन, मैंने पढ़ा ही नहीं. ठीक है? तो आंसर्स में ना बहुत सारा साइंस नहीं लिखना है until unless it's a साइंस क्वेश्चन. साइंस सिर्फ साइंस के उसमें लिखिए. ठीक है? यहाँ पे बहुत ज्यादा कुछ साइंस का फॉर्मूला और इक्वेशन लिखने का बिल्कुल कोशिश मत करना. जितना ज्यादा लिखोगे उतना कम नंबर मिलेगा. ठीक है? तो बिल्कुल सिंपल भाषा में लिखना है, जैसा लैंग्वेज में एनसीईआरटी में लिखा हुआ है. योर लैंग्वेज शुड बी एज सिंपल एज एनसीईआरटी लैंग्वेज, देन ओनली यू विल फाइंड मार्क्स इन जीएस. ठीक है? प्लीज कीप दिस इन माइंड. दैट्स व्हाई आई डेलिबरेटली डोंट गिव यू टू मच ऑफ साइंस वर्ड्स एंड इक्वेशंस एंड टर्म्स. ठीक है? राइट. सो इतना काइनेटिक पोटेंशियल तक चल जाएगा, बट इससे ज्यादा एक्सप्लेन मत करने लगना. राइट. सो शुड वी राइट फर्दर? Height we have written and the speed we have written, okay, and the width we have written. Width of the wave वो नहीं लिखा है, वो लिखिए. The width of the wave might also reduce down to, the width of the wave might reduce down to nearly 8 to 10 to 20, 30 kilometers. 8 to 30. You write this way, 8 to 30 kilometers width. So earlier it was 100. Now it has come down to, can you see, है ना, काफी almost 7-8 किलोमीटर तक नीचे आ जाएगा वो, right? Okay, full stop. Now what will be the effect of this? Now tell me, just imagine, and because I've given you all the numbers, what is the speed of the wave? Up to 50 kilometer. What is the width of the wave? Minimum कितना है? 8 kilometers. So if the width is 8 kilometer and the speed is 50 kilometer, how many waves can come and hit the coast? Around 5-6 at least. And if it is 30 kilometer, then 1 or 2 in 1 hour. Do you understand? So basically, how many tsunami waves can hit the coast? From 1 or 2 to 5 or 6 waves in an hour. This is what I want you to understand here. Okay, that's why I'm giving you the width and the height and the speed, everything. ठीक है, अगर किसी चीज का 10 किलोमीटर 100 किलोमीटर width है, right, और 800 किलोमीटर speed है, तो 8 times 8 waves. उसी तरह से यहाँ पे क्या है? The speed is 50 and the width is 10. Let us say 8 का 10 कर लो, तो कितना waves आया? 5 waves. अरे समझ में? And if the speed, if the wave is, let us say rather than 10, it is 30 kilometers. So you will get something like 1.5 wave in 1 hour. Right? So this is what I want you to understand, that when tsunami waves come, they don't come as single wave. Right? It's not just one wave. It could be 1, 2, 3, 4, 5, 6 waves coming one after the other. And normally the first wave might not be the biggest. Okay, so maybe you have one wave coming and hitting. After an interval of 10-15 minutes, another wave. And maybe that is bigger. Okay, so this is something that you have to understand here. It's not a single wave phenomena. Tsunami can come in multiple waves. It varies from place to place. Okay, so I think वो height आपने width भी लिख लिया ना? Now write down hence we can calculate that from 1 to 5-6 tsunami waves, from 1 to 5-6 tsunami waves can hit a coast, can hit the coast in an hour. Full stop. When a wave, next, continue to write, next paragraph. When the waves hit, every wave would generally have a high part. When the waves hit, every wave would generally have a high part, because every wave has a high, right? So would have a high part as well as a low part, right? Every wave will have a high part as well as a low part. Okay, so what will happen when the high wave hits you? How high is it? 100 feet. आपका इस रूम में बैठा है वो कितना हाइट है? क्या लगता है? ये कितना हाइट होगा? 8, मान लो सपोज 10, तो ऐसा कितना फ्लोर? That high. That is the height of a tsunami wave. And what is the speed? 50 kilometers. So सोचो उतना बड़ा बिल्डिंग कॉम्प्लेक्स, एक बिल्डिंग नहीं, बिल्डिंग कॉम्प्लेक्स 50 किलोमीटर पर आवर का स्पीड से आपकी तरफ आ रहा हो. You know, that's why tsunami does not only have a physical effect, it also has psychological effect on people. It can destroy you from inside in that moment. आपके सामने से एक ट्रक उतना तेजी से आता है तो आपका हार्ट बैठने लगता है. Now just imagine 10 floor high building complex in Gurgaon, whole Gurgaon moving towards you at a speed of 50 kilometer per hour. ठीक है? So this is the effect of tsunami. ठीक? So now, but this was the high wave, right? When the low wave will come, what will happen? Sea level से high 30 to 50 feet. Then low wave means sea level से low 30 to 50. तो मतलब क्या जमीन साफ करके आएगा? Water will not come. There is no water between the coast and the next high wave. So almost for that much distance, there might be almost no water. That is what you call as a low wave, which means if you are standing on the coast, then in front of you up to maybe half a kilometer, 1 kilometer on the coast, there will be nothing. That's a region that you never get to see, except for during low waves of tsunami. Okay? So normally the tendency is that if someone, let us say by any chance you survive the first wave, right? वैसे तो chance कम है, but still. So if you survive the first wave, then what happens is the low wave comes, and when the low wave comes, the water recedes back. When the water recedes back, people think the tsunami is over, because अब तो जा रहा है. ठीक है, वो जा नहीं रहा होता है. वो next को ला रहा होता है. ठीक है. So normally people tend to walk toward the ocean to save whoever is left or whatever is left. By the time they have already walked half a kilometer, then they see the second one coming. पहले तो कोस्ट पे था, बच गया. अभी half a kilometer आगे और लेटर से बहुत सारा सामान भरा हुआ है. Then you are heavily loaded also. ठीक है. So this is why the second wave and the third wave of tsunamis are generally also highly destructive. Right? So basically the idea is, what I'm trying to tell you is that when we see the water receding on the coast, going backward, what does that imply? A more than normal recede on the coast is a sign of arriving tsunami. Right? Because it might not be that the high wave reaches you first, it could be that the low wave reaches you first. Right? ऐसा जरूरी नहीं कि first आपको high wave ही मिलेगा. Maybe the first part of the wave reaching you is the low part of the wave. Then what will happen? The water will be there on the coast, then gradually the water will recede and it will keep moving toward the ocean. ठीक है? Now people who don't know this on the coast, they generally tend to think that this is new sign, कुछ मजेदार है, चमत्कार. ठीक है? जैसा इन्होंने बोला. ठीक, but वो गड़बड़ हो जाता है. And only traditional people who know this, right? That's why when we had a tsunami in 2000, the early part of 2000, many of the tribal people on the coast, especially in Andaman Nicobar, they hardly had much damage to them. Because when they were on the coast and the water started receding, they started running the opposite side. They knew ये tsunami है. Right? That's traditional knowledge. Whereas people who were new, आपके जैसा बीच पे गया था अभी गोवा घूमने, मतलब दो बीच पे गोवा में नहीं आया था, but they were pretty excited. सबने आइस का तैयारी तो किया नहीं है, आप लोगों ने किया है. ठीक है? तो नेक्स्ट टाइम कभी बीच पे गया और पानी अगर पीछे भाग रहा है तो आप किधर भागेंगे? ठीक है, फ्रेंड बोलो, उससे मैं खुद को बचाना है. ऑलराइट, और जो आसपास है उसको ही बताओ. अगर कोई बोले भी बहुत आइस का तैयारी किया, इसके दिमाग में पता नहीं क्या क्या चलता रहता है. ठीक. ठीक है? Do we get it? So hopefully everything is clear. You understand this also, how the phenomena you will, experience and all. So this is the last part that we have to write. Should we just complete it 5 minutes? उसके बाद छुट्टी, जाओ, सुनामी भी खत्म. ओके, नेक्स्ट क्लास में, क्योंकि आओ पिछला क्लास में सुनामी चल रहा था, वापस आओ शुरू में ही सुनामी, तो मतलब मजा नहीं आता है ना. तो आज का क्लास कंप्लीट करके 5-7 मिनट में, देन लेट्स, ओके, सो राइट दिस डाउन. Okay, so I think the last line we have written is the low wave. Did we? The low part. Okay, so just continue with that. When the low part arrives, the water recedes. When the low part arrives, the water recedes on the coast. The water recedes on the coast as a sign of, water recedes on the coast as a sign of arrival of the next tsunami high wave. Next tsunami high wave, which might arrive over an interval of 10 minutes to an hour. Which might arrive over an interval of 10 minutes to an hour, and which could be equally or more destructive. Equally or more destructive. Okay. So this is that whole high wave, low wave, everything. Clear? Now the last part, where all tsunamis are generated. That's why I asked you for 5 minutes. अभी 1-2 मिनट ही लिखा है आपने. So tsunami genic regions. Tsunami genic. TSUNAMI. Tsunami genic. That's a single word. Tsunami genic regions. Tsunamis are created or generated, created, whatever word you are comfortable. Tsunamis are generated or created from the Indian context. From the Indian context. First we are writing from Indian context. Tsunamis are created from the Indian context, mostly around the Sunda Trench. Mostly around the Sunda Trench. Sunda Trench. What region was that? Where the Indonesia, Malaysia islands. We call it as the Indonesian tsunami genic region. This region. Sunda Trench. Within bracket, Indonesian tsunami genic region. Sunda Trench. Within bracket, Indonesian tsunami genic region. Mostly causing tsunamis on which coast of India? From here, which coast of India will we get? Eastern coast, right? Causing tsunamis on the eastern coast. Indonesian tsunami genic region causing tsunamis on eastern coast. So this is for the eastern coast. Most of the eastern coast tsunamis in India come from this region. Okay, the Sunda Trench region, which is the Indonesian tsunami genic region. For the west coast, next line, next paragraph I should say. For the west coast, the most of the tsunamis generate around the Makran coast. I'm writing the spelling here. The Makran tsunami genic region. MAKRAN. Makran tsunami genic region. Around the Pakistan-Iran coastal region. We call it as the Makran tsunami genic region. Okay, Makran, MAKRAN, Makran tsunami genic region. So any of the earthquakes taking on that coast might create tsunamis, which might hit. All right. Then, but the most tsunami genic region are the subduction zones. Most tsunami genic region are the subduction zones of the Pacific plate. Subduction zones of the Pacific plate. Okay. So that's your major tsunami genic regions and the tsunamis and all this. Clear? So with this we end this tsunami story here. Right? With the tsunami we have also completed. Online people, there are 3 of you who have asked me some calculation thing. I'll just come to that in the end of the class. So just give me 2 minutes. Okay. So with this we have completed tsunami. Next class we are starting with geomorphic processes. Okay. So exogenic, we have already done endogenic movements and forces and processes. वो अभी आपको पता नहीं है, but वो हम कर चुके हैं. ठीक है? So next class we are talking of exogenic movements and processes. We are doing exogenic movements and processes and NCERT chapter number 6 and 7. And I would expect you to read 5 also, but please, all of you, be slightly careful here and please listen. There is a chapter number 5 in your NCERT, which is rocks and minerals. You don't have to memorize that chapter. वो सिर्फ conceptual chapter है आपके लिए. There are lot many facts, don't memorize it, not needed. Just understand 3 things from that chapter. Igneous rocks, sedimentary rocks, metamorphic rocks. If you understand this much, good enough. उसके बियॉन्ड यू डोंट नीड टू गो. Lot many minerals are given, lot many rocks are given, वो सब नहीं पढ़ना है. UPSC has never asked a single question except for igneous, metamorphic and sedimentary rock concepts. ठीक है? And after that you directly jump to chapter number 6, geomorphic processes. And in your GC Leong you have a chapter by the name of mass weathering and mass movement and all that. Chapter number 4 है या कुछ ऐसा है. ठीक है? You can read that also if you want. Only that chapter. But if you want to avoid GC Leong, you can completely avoid GC Leong here. It's not necessary. It will only be value addition. पहले necessary क्या है? NCERT chapter 5, chapter 6 and chapter 7. That's it. ठीक है? So next class we are doing that and we'll be trying to complete that. Okay. Rest of you please go silently, चुपचाप से बाहर चले जाओ because there's something that I have to explain in terms of calculation to others. तो बिना आवाज किए जाना. Any doubt? Any other doubt from you people? हाँ बोलो. The cost of, and as I said, please do not talk because फिर मैं बोलूंगा इनको माइक में आवाज नहीं जाएगा. तो थोड़ा बाहर जाओ, आराम से गप्पे मारो, बट यहां मत मारो. Yes. In the Daman Diu region. हाँ, that is a tidal phenomena. Tide. ठीक है? तो वो हाँ वो हर रोज होगा, वो टाइड है, वो आएगा. ठीक है? We'll talk of tides. Okay. Now some people have asked online, sir, should we just close the eyes and give up on the calculation? वो समझ में नहीं आ रहा है. Calculation was simple when I was talking. I'll just bring you back to those calculations. यहाँ पे देखो. This diagram. यहाँ देखिए. Now what we are finding is the speed of the wave is 50 kilometers per hour. The width of the wave I have given ranges from 8 kilometers to 30 kilometers. That is the width of the wave. And the speed is 50 kilometers. So if I ask you, how many waves will cross my hand at that speed? And the wave width being 8 to 30 kilometers, you can say that, let us say, rather than 8, let us say 10. Okay? And 50 kilometers per hour is the speed. So 10 kilometers is the width, 50 kilometers is the speed, so 5 waves will cross. अगर 8 कर दें तो 6 waves will cross, right? So 6 waves will cross. And if we take the bigger waves, 30 kilometer wide, then you can say 1.5 wave. That's what we have written. Okay. So wave calculations were not too difficult. I hope everyone understands, especially Karthik, Abhay, and one more. कौन है? Pratima. अबे आंख बंद करने का जरूरत नहीं है, इतना जल्दी हिम्मत मत हारो. Okay, that's it. Thank you. Ma'am, is there anything you want me to take up? Any other doubt? Nothing? That's it. Thank you.